All right. All right. All right. All right. We should get started. Hopefully my mic works this time. You guys can tell me if my if you can actually hear me this time. Last time I did this, I came on and there was no mic. So, all right. Good, 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 good. I'm stoked to have you all with me today. I'm stoked about the topic today, I have to admit. I might be like pushing it a little bit, but this is where my head's at. I mentioned a few streams back that we'd be, changing up. I spent a lot of time, about 2 years when I started, interviewing every single person in the meta framework space, right? Trying to understand what Nux did and Next did and SvelteKit and Remix and just working my way through all that. Then I spent last year doing a lot of R&D around solid start. What are the best patterns? How do RCs work? We spent a lot of time dissecting this stuff. And we're now at a point, well, if you saw the announcement, that solid start is reaching 1.0, which means, that's a long journey. It's been 3 years, and both of basically the first 2 years of the stream was all in support of that. I'm back to talking reactivity. I don't know if those people out there realize it. The last time that I did any kind of significant change to the reactive system in Solid was probably September 2021. So like almost 3 years ago. We haven't really changed very much since then. And it's kind of crazy when you think about it, right? Because we had stuff like transitions and concurrent rendering and suspense and out of order streaming and all these things for years and years and years. And they're becoming the thing that everyone's talking about: fine grained rendering, signals, but we've had a lot of time to kind of think about where to take this next. And I would have loved to have worked on this stuff earlier, but small team, even if we multi-thread stuff and have different people looking at different things, me myself have a hard time, if my job is to get stuff out the door, I have a hard time necessarily multi-threading too far. That's my thing. But anyways, that's why we're here today, right? I should say hi to a bunch of people. Happy birthday to me. Well, happy birthday to you then. Yes. I think Alex from our community just had a birthday too. He woke up to bear the mention in the Solid Start release, thanking him, and he said that was a great birthday wish. So yeah, birthday's around. Hi everyone, how are you doing today? Yeah, not first, but hype, definitely hype. Signals the sequel. Yeah, that makes me think of that when Michael Rawlings joke about signals during Signals Week. More hype, yeah. Signals 2. Yeah, okay. The title of the stream, well, at least the image, is a little bit provocative or suggestive. I'm not going to apologize for that. It just, I feel like when we say signals, it means a lot of things to different people. I was just actually talking to Ryan Florence on Twitter, trying to clarify what, the difference between signals and backbone events were. Like, so even putting a 2.0, is pretty extreme, perhaps. But I think there is an evolution along this path. And I'm seeing this while working with the people in TC39 on the signals proposal, right? Because there's like, what's the minimum viable product now? And honestly, if you ask me about that now compared to like a few years ago, I would say this stuff's a little, different. So even calling what's coming out there as Signals 1.0, so to speak, isn't really fair. So we should talk about that, right? The thing is, for Solid, at 2.0 is about returning to the basis, right? Solid Start represents the greatest extent away from the core we could go, right? You start with this, the core is the signals, is the reactivity. Then you build some stuff that can render on top of it, and then you build some component libraries, and you build a router, and you build all these pieces to finally put it all together and layer it as far as you can with Solid Start. And the journey of Solid 1.0 has been that. When we started, people told told us what we were doing wasn't possible. Like, that's just not how things worked. It wouldn't be performant, it wouldn't scale, it'd be messy. You know, we heard tons and tons of, you know, criticisms about this. And I felt, and a lot of the work here was to prove that we could do the full picture from end to end, and not just do it well. But what that's mean is we've had to build out every other piece of the ecosystem in the process. How do you handle metadata? You know, how different CSS style stuff. Things I'm gonna admit challenge me, because there's zones that I care to be building general solutions in. There's other zones that I want to leave it open to others to build solutions in. Solid Start was a challenge because we wanted it to still be a general solution, even at the probably most opinionated layer you could get at. So I'm very excited to return to my roots, return to, you know, just the reactivity that powers it all. Anyway, sorry, I'm still like getting through chat when people are just saying Signals 2.0, Signals good, woo woo. People are excited. You know, good. Yeah, mic check. I'm like 10 minutes behind in the chat. Sorry, guys. All right. Okay, I'm just catching up. Okay. DAG 2.0. Yeah, exactly. The conversation with Ryan Florence. Rust. Well, what does Rust have to do with it? But sure, let's have Rust represent. We got signals in Rust too. We got signals in Dart. I don't know if people seen it. There's Solid Dart, which is a Dart signals implementation. There's signals, like, I guess, like my name. There's signals everywhere. It's not an understatement at this point. I mean, yeah. Finally, a non-managed administrator. See, if I'm only here, I must be way behind on the chat. Sorry, there's just so many of you today. See, and this is an interesting question, right? Because I've looked at many of the other reactive libraries over time. I've been working with people in the TC39 who are involved around like Ember. I actually haven't talked to Yehuda Katz much, you know, at all, really, outside of a few Twitter conversations, like in public. So I can't say much on that. I thought Starbeam's idea of resources was interesting because it's a different model. I'm going to talk a bit about the model we've been using for the last, like, oh god, 8 years now. But yeah, I think we're in the same zone. I want to talk about what problems we want to solve, what layers onto it. There's a challenge when you're dealing with primitives that you could just like keep on adding them. And I'm trying to understand what the base set is and what the minimum requirement is here. And to be fair, I'm not straying too far from what we've done to date. So this is definitely going to have our slant on it. But our slant, as it turns out, is been what people is the direction others are taking. You know, things like Vue Vapor, things like Svelte 5, and like signals. Like watching that Angular keynote the other day was amazing because like they said it so matter of factly. You know, they're like, oh yeah, I forget, there was like a place where they had a slide up and they're like simplicity, maintainability, all these great qualities of them using signals. And I'm just like, it's awesome to see that, because when I started, that was the thing that was in question. And now we're talking about, you know, Google Keynote, where it's just like the assumed standard. It's like, yeah, of course, this is what you get. So yeah, we've come a long way here. Yeah, there. I don't know. I don't know if to spend the time. And to be fair, we are looking at implementing the browser signal spec as a base to build a new reactivity off of. It's potential there, but that's not where my like complete focus is. I want to explore the possibility first. That's what I've always been about. I want to look at what we want to accomplish. Hi, I'm new to this. What pattern do signals follow? If I mean general sense, or if we're talking like gang of four patterns, it's the observer pattern. But it goes, you know, it's a bit more than this, because in a sense, signals really originate from a lot of the research around synchronous reactivity and synchronous reactive programming, and this, you know, is influenced a lot by like digital circuits, like if you've ever done any kind of what is it, FPGA programming or whatever, like digital logic, VHDL, Verilog, you'll know what I'm talking about, where there's this idea of like a clock cycle, and essentially whenever changes happen, they all apply at the same time. It's not like this, then this, then this, then this. Even if you write your code a bit like that, you're describing a set of rules that occur on each tick, and signals are direct from that line of academia. If the signals problem makes the browser, will frameworks become faster in building JS without signals? I doubt it. I mean, signals are still an extra primitive concept. And if we were to actually finish the story, we have to talk about effects and DOM updates. And I think, like, it's interesting, right? Because people are wondering, like, maybe if we could fold the whole thing into the C level, it never even needs to get out to the JavaScript. I don't know. I'm suspect, but I think there's a lot of difference in effects, and we'll get into that a bit, because I'm going to get into the definitions here and what I think about what 1.0 or whatnot means. People excited about the solid start. Hey, Fuzzy. Yeah. Tori is signals plus Rust. I mean, people using solid with Tori is you know, a bit of that, but I was actually talking about like Leptos, where the signals are actually in Rust. What's my drink of choice today? Okay, now we're getting to the important questions. It is still this coconut water that apparently, oh, actually, one of my lights isn't on. Yeah, I'm like, it looks really murky, but to me, it looks like a nice pink color. It's just the condensation on my glass. Anyway, how the signals and BDOM related? They're not. All right. Okay. I think I'm finally catching up to everyone. Fellow coconut water enjoyer. Yes. Solid native when? Well, I have no intention of building own native platform. It's a lot of work. If you just saw the React Native release, you know, and they have a whole new architecture. They've been working at this Facebook with like a team, a sizable team for years working through React Native. We don't have those resources. If you look at the approach Solid has taken over the years, it's maintainability is a huge part of our concern, because we recognize that we are a bunch of open source volunteers. We don't have full-time team of, I don't know, 40 devs or 60 devs or whatever. You know, I'm just pulling numbers onto my hat, sort of. Some of those numbers are real, but you know, working on these projects, like, on the other hand, do you want to use mobile with Solid? Easily. We already did streams on this. You can use native script, which, you know, not everyone might say they want that, but I was quite impressed by it. That very one-to-one API approach. There's Tori mobile, which we were just talking about. Another great option. Both of those allow a very native level kind of interop. There's obviously things like capacitor by Ionic, which is more the web view approach to my understanding, but like there are decent solutions on mobile, and I think they're just going to get better. And I think we should put support into that, because let's be fair. Vue and Svelte are also going to be in that same boat. They're going to want to kind of get in there. They also do not have, you know, a huge team to build the native development up. I think we should, this is part of my choose your battles layering thinking. Yeah. This is my actual shelf. It's just my office isn't situated this way. In reality, like my shelf's over here. Well, the thing is, if you address the primitives, you address the base, then people can do whatever they want with it. So that's why 2.0 is early. I would have come back here earlier if like, I kind of joked back in the day. I didn't want to build solid start. I want someone else to build solid start. Because I was like, the farther away you get from the core of the framework, like you build solid start, you build solid start, you build whatever thing, go for it. Like the way Next was built. But the reality of it is to get adoption these days, people expect, to have all the features, and we had to take this to the extent even to prove that it was possible before people would take us seriously. And that's just the reality of it. It is what it is. Do I feel like we've sunk more time there than I would have wanted to? Yeah. But I mean, once I was involved, that was the danger of it. I wasn't going to settle for something that wasn't up to the standard that we had of Solid itself. So, yeah. Thoughts on Diax Live View? I mean, not to hijack too much, but sure. Quick thought. I think stateful servers are interesting. I think they're a technology and place that I'd want to do more with. That being said, if I had the ability of stateful servers, I'd still not diff. I'd probably use signals and go for a more reactive approach. A Dioxys is a diff-based approach, which like LiveView itself is, but I think we can do better. But that, again, Rust on the server is super fast, so it is what it is. But the other bigger part is, today, most front-end frameworks work on the premise that you won't have stateful servers. That's the baseline, so they don't make those assumptions, which means while I quite enjoy the simplicity of the live view model, there's a whole section of people who can't today actually just pick up that model. All right. We should get on topic at some point. Probably. This is reminding computer and streaming to Nitro. It's weird. Every other adapter other than that AWS one works with streaming. So I don't know what's up with it. Like, in fact, the Netlify and Vercel AWS functions, like their functions that run on AWS, also work with streaming. My Hacker News demo I deployed to everywhere. Even Amplify works with streaming. I deployed that just the other day. So I don't know. How are we doing? 233. Did new people just join on, or did I get rated by someone? Probably too early to get rated. Good. I am in software and development, at least on Twitch. So that's good. And Dev, thanks for the sub. 13 months. That's awesome. I missed that earlier. Thank you very much. Probably one of the longest Twitch subscribers we have. I say we, I mean I do. Dax Brian interview when? That's a great question. I don't know. I don't know if I would. Yeah, okay, sorry. It's good. Nevin versus can have their own adapter and not the rep lambda first. Gotcha. Yeah, I think I take everything too seriously. I think Dax would hurt my feelings. Yeah, it'll happen. Oh, front end masters. Hey, there you go. If you haven't seen my course there, I'm actually going to talk a little bit about the stuff related to that. It's more like a sequel to the front end masters course, because the first hour or two-ish of it, I talk about the basics of Solid and I talk about the reactivity system. And I want to talk today a bit about, I mean, we should just get this rolling, right? It's hard because it seems like, there's so much energy in the air right now, but the way we teach reactivity, I think, has to change a bit, or should change a bit. And I think that'll help people adopt it. I say that after literally trying to perfect the Solid explanation into 5 minutes. If you guys aren't familiar, Attila Pacina DX on Solid, managed to make our intro video into 5 minutes to condense the whole explanation that, I take, originally hours to explain. But I think we need to relook at this a bit, and that's a part of what I want to talk about today. Yeah, I hear you, Joe. But the truth of the matter is this, like, there's so many people that it's just like next is default option these days. There's like this simple happy path, and there's this mentality, and it's even being kind of bred by the React team, right? In the sense that it's like you need a framework to to do React. That's kind of where we're at today. And while not everyone fits into that bucket, that's kind of the thing. Ooh, hey Jadon. Speaking of which, Jadon is going to be on the show pretty soon. I believe next week, and we're going to talk about Wiz and resumability and all the cool stuff that goes along with that. So, yeah, exciting stuff. I know we're just starting up here. I'm playing with chat, but yeah. Well, I mean, Wiz is the original resumability framework, to be fair. That's why we need to talk about this. I wanted to have Jadon on for a while. I was always like, is there going to be like some like NDA Google stuff we have to worry about? But I think the perspective around the Wiz has changed, and in good part thanks to the narrative that Misko and Quick have pushed. People care about this outside of large corps and outside of Google. Yeah, finally some public content on Wiz, exactly. And where better to find it? Right here, right? Yeah, Malte was one of the, my understanding is one of the co-creators of Wiz, or they started a small team, and he was one of the like main guys near the beginning of Wiz, to my understanding. But we'll get all the details about that next week. So, yeah, I mean, we should talk about that, because I mean, we will talk about it a bit with Jadon next week. But the one thing you got to give some credit to, both on the Marco and Quick side, is Wiz was not that approachable a few years ago. Like, actually figuring out how to make it develop, like, you can come up with the most brilliant solution, but actually trying to come up with a developer experience that developers love is a whole other thing. And our job as framework authors is to marry them both together. And I think the direction that Wiz is going is definitely, on that path. But I'm saying it's like, it took a lot of work and rethinking to get there. Anyway, yeah. Geez, we're just talking crap, and it's already been half an hour. Okay. So I actually made some notes for myself today, so I try and keep on topic. But as I said, keep chatting with me. It's all good. So I already talked about what Signals 2.0 is. Yeah, what is Signals 2.0? It's looking at rethinking the kind of core abstraction primitives around signals. I'm not saying like we get rid of create signals, so to speak. I'm just saying look at how things have to adapt to meet the needs that we want today, because this has been a very long running thing. What is Signals 1.0? Well, because it's got to be a 1.0 before a 2.0. It's not as clear of an answer. In 2022, 23, every library started adopting signals in some sort of way, but even those were quite different. And you have to understand, like, when I started teaching signals, I taught them a very different way to how they work today, right? When we teach signals, we teach push, right? Yeah, I'll give a shout out here. I actually, Nolvox, whatever, I can't pronounce name. Been long involved with the Ember community, and done a lot of great work around Ember reactivity. So I'm just gonna, and big push on, I keep on seeing promoting like Starbeam, which is a universal reactivity thing that Yehuda from Ember came up with. Yeah. So yeah, show me the code. We'll get to code in a bit. But let's start with, well, actually, let's get to code right now. Why not? I'm just gonna open up a playground for fun, and let me share my screen and present. See, if you've ever watched me, let's see here. Is this one? Yeah, let's go. Cool. Everyone can see that? If you ever watched me teach reactivity, or most people, even I've been noticing Evan gives a similar talk. I don't know when he started doing it, but it probably would have been after they released the composition API. I think I wrote an article. Some of you might have seen it. What was it? I think it's on page 2. It's been that long ago. It was called Hands-on. No, not that one. It was, well, I think it's linked here. Building a reactive library from scratch. And I made a very, very simple reactive library. Create signal, whatever. I actually grabbed the code from this simple reactive library, and I'm just gonna paste it into our playground here just to kind of show something, right? Because I think this level of understanding, and I'm not going to go over this in crazy detail, I expect you to be somewhat familiar with this, is at least important to understand or talk about where we're going right now, okay? So, as usual, I'm going to give a little bit of background. Okay, good to know. Starbeam is still pre-1 when in production, so don't try it on real projects. Like Angular is, do you think any other frameworks might be candidate to merge with Solid? For example, Quick. Quick is probably the most likely framework, like the closest to Solid. I would agree. So this is definitely something that me and Misco talk about joining efforts. Talk about just the other day we were talking about, like, if I could work on this new version of Signals, they'd want to adopt it in Quick, and at a certain point, who knows, right? But we'll get there. Let's start with the basic version of Signals. What's this? No, that's not in here. That's not in my article. Sorry. The most basic version of Signals involves create signal, which is a read function that when it reads something, it checks if there's a currently running context, and then it subscribes. And then when you write the value, you notify everyone. And the reason and there's even this cleanup function that goes through and removes dependencies on both sides. And then there's createEffect, which simply pushes itself on the stack, pops it off. But if you remember in that article, I got to the computed value, I got the create memo, and I just said, oh, let's write a signal and have an effect right to that signal and call it a day. And I kind of breeze it over and I go, yeah, this isn't how it really works. But it'll work for our, simple example. And the reason is this system that everyone teaches, reactivity in 50 lines of code, because you can, if you forget about the create memo, it's 50 lines of code, I'm going to turn off the notifications on type check, is a push-based system. And that is not actually how any of the signal libraries work. We teach it to make it simpler, because what you can do in a push-based system is you can go, we'll just use Solid's syntax. We can go create signal, and I'll put a 1, and then what I'll do const double. I mean, everyone, at this point, this is like hello world in a reactive system, pretty much, right? And we'll go s times 2, and maybe we will do createEffect, and it's going to go console.log double. Okay. And if all goes good, oh, right. Yeah. like get my console back here. If all goes good, we're gonna see this 2 in the thing. Can I blow this one up too? I can't. Hopefully you can see there's a little 2 here. Okay. But this is the basic example, and then you go like, let's set to 2, and now you see 2 and 4. So it runs once, you see 2, runs again, you see 4. Now, if I set it to 2 again in my basic example, you're going to see this little colorful 2 here because it console logs 4 twice, which seems kind of wasteful. So the first change we make in an actual reactive system is when we write the new value, if it's the same early exit, right? If value equals next value, or do some kind of object check or whatever, just return. And if we do that now, we're back to, even though we set the value, you know, I can add another set 1 here because it starts at 1. You're only going to see 2 console logs, even though we called set 4 times. This is basic kind of reactivity. You see, for signals, you see all the principles in play. The problem is this is a push-based system, and it's not how an actual signals-based system works, right? People following me so far, right? So what I mean by that is, okay, this effect, that's fine, right? But, you know, we can also like get rid of the effect and do something like this. We could, let's say we call double, right? Because one of the cool things about a reactive system is that you can just access the value. So I'm just going to call double at each point, right? People always wonder why I called solids computeds. Everyone else calls them computeds, and I called them create memo, like React. And they're like, why did you do that? Well, if I put a console.log in here and said, hey, you know, s times 2 or something, I'm not running the effect anymore, but what you see is there's still 2 console logs, because the first time it runs, you call double, it prints it out. When it setting it to the same value and calling double again doesn't rerun this function, right? And then setting to 2 and calling double now calls that function, right? And if I call double one more time here, it's also not going to call it again. So from the kind of reverse view of this API, asking for the value multiple times does not have it run anymore. So like, while this is a push-based system, this is already getting away from RxJS or Backbone, because it's a push-based system with memoization. To be fair, this system breaks pretty hard with the diamond problem, if you're familiar with it. Like if we had multiple dependencies, I'm not going to go into that because this is already a solved problem. But I wanted to talk about why when we teach reactivity, it's kind of limited. Well, we're at 320 people across both streams. This is probably the biggest stream I've had so far. And I'm like looking for the raid, and the raid didn't happen. This is just naturally everyone being here. That's so awesome. Okay, let's keep on going. So this is a push-based system. So, and I said signals aren't quite a push-based system, right? You could argue this is a push-based system with auto memoization. See, on the other hand, you know, you always hear people talk about React, and React goes, we're so simple. Well, why are they so simple? Well, let's look at the alternative way of looking at this. What if instead of doing this, I'm going to console out a bunch of other stuff. We instead just go, okay, well, let value equals 1, okay? And then I'm gonna make a set function. We will see why in a minute, but we'll say that value equals v, and now we have const double equals equals value times 2, and let's see here. And what else am I missing here in our example? Oh, right. I should probably put the console log in so you can see it, because this is a basic poll-based system, right? If I go, hey, value times 2, we have our console logs here, right? I'm still calling double and set and double and set. There's something you're gonna notice here though. They're logged 4 times here, 2 on the first value, 2 on the second level value. So the naive poll-based system, and by poll I just mean you just ask for the value, right? You just like go get me the value, and then it polls and asks this, and it just pulls to you. Calling a function is just a pull, right? Right. So like, how would you check this, right? Well, I mean, the first problem is this isn't very optimal, right? Because you're running it all 4 times. So what do you do in React or any framework that uses pull-based system? You go, okay, let's introduce our own function. Let's call this one memo, just for sake, right? What memo takes a function, and then let's see, how are we implementing memo today? Let's do something like what last. I want to say, let's say last input we're going to need, and I'm going to use an array. I'm just running a memo function. We probably get this off, of, I don't know, like npm or something. But I'm picturing something where you like return, like, I don't know, the same function with the args, and then we kind of like, we'd have to go through all the args, right? So like let I equals 0, I. This is very naive. I'm sure there's like loopholes, like if you pass an argumentless function, but args.length, I++. And then what we're going to do essentially is if at any point args I does not equal last in I, we're just going to return the function with we're going to call the function essentially. And actually, let's get a little bit fancier than this. Let's actually, what do we want to do here? We want to say last in equals these args, and then last out equals here. So now we've updated those. And then basically, if we go around and we realize the arg's the same, we're just going to return last out, right? So I just wrote a very basic memoization function. So you take the original function, returns a version that doesn't call it again unless the arguments have changed from the last time it ran, like a one-def memo function. So if we go back here and go demo and go memo this, hopefully it's like I did something wrong. Oh, you have to actually return the value. But no, what did I do wrong here? Oh, right. You need arguments here too. So let's pass v into here now, right? Just for simplification, but you can view this like the dependency array in React. Sorry, and it's not v, it's value. Value. Yay, okay. So I did it. We were back to a single console log for each of these. Hopefully you can all see this and can follow what I just did. Essentially, yeah, I can get all this reactive stuff out of the way now. I'll keep it up here just in case I want it later. But essentially, we wrote a memo function, and now it has very similar behavior. Well, sort of similar, because our problem now is like, how do you write an effect when we do this? Yeah, but we'll talk about eager and lazy in a minute. This is why I'm actually laying this out. So how do you do an effect in this system? Because sure, we can see that these are derived values. Well, we can add our own effect function. Let's add effect function. Let's make effects array. So let's go const. I mean, this is really inlining it, but let's do that, and let's make it like function effect, and then all we got to do, I think, is just what, like effects. Actually, this one's going to take a function. I'm going to go effects dot push function. Okay. And then on the other hand, we need to probably, let's see here, in our setter, where's our setter here? Instead of just setting the value, like you could think of this as like in a component registering its effects, then we would go through like for, let's use I again, equals 0, I smaller than effects dot length, whatever, I plus plus. We will kind of go effects I, and we'll call it, right? So now if we bring back our effect, essentially, right? This way we don't have to call double ourselves a billion times. Hopefully, go effect. Now double takes value. You know, we can see it. Well, actually, there's a problem. 2 runs once, because by the time but the reason it's running is because the effect doesn't run until I call this first setter. We're back to double executing again, even though like we're memoizing our function. So technically, we have to memoize our effect as well. Like basically every time I call set, it just goes through and calls them all, and we don't want to necessarily call them unless something changed. So I'm going to, like, this is really hacky as hell, but I just want to show kind of conceptually what like React hooks are kind of doing, right? So we're effects push memo. Now we memo that function as well. And let's just pass double and value to here, and then dv, and we get the logs like we expect. They only log one more time. So as long as we just keep on memoizing everything, our poll-based system can be pretty efficient. But this is kind of like, you can see the difference between the push-based system, because the push-based system had the ability to like just like not even care. It just like knew via notification what effects need to run. This one, you kind of go like, every time I set, I need to like go check, run the stuff, use memoization to save myself from extra execution. Okay, people following? You're right, and I could have done that, but now it's too late. See, not thinking. Oh well. I am sorry. Run it back. I'm not running it back. Yeah, this is the best part about our playground. We can literally take snapshots at each stage. Well, I mean, let's do this. Let's snapshot this one. Okay. Right? So this is pull based. Because I'm actually done with the demo I wanted to do. And then I'm going to go hopefully all the way back, undo everything I did. All the way back. Take another one of these. Push based. Thank you. All right. So what's the point of this whole lesson here? Because actual signals, as many of you know, are push-pull. They actually do both. The funny thing is, solid is also push-pull, but it's actually more push than pull, and newer systems are more pull than push. And that's why, like, the reason I'm talking about this in terms of what signals 1.0, 2.0 is solid 1.0 or the new one's 1.5. I wanted us to start thinking about the complexity and the considerations that come into these trade-offs. I wrote an article, unsurprising to most of you, that I wrote an article called Derivations in Reactivity. State is function of state. Great article, right? Yeah, they made it just for me, right? But this article is good for helping people understand the difference between push and pull and push pull. But that's not completely why I'm here, because again, I told you, we teach push. When I got to push pull, I was just like hand wavy, and then I'm like, read Milo's article. I didn't actually get into it. And if you care to get into the details of push pull, you can watch my stream last year with Milo, where we talked about it for like an hour and a half or 2 hours. I think it was an hour and a half with Milo. I also had the guys from Angular talking about their push pull system for like 2.5 hours on stream. So there's plenty of content to talk about different push pull algorithms. I don't care about the way you choose to do push pull. I care about the implications of different decisions that you make, not performance, not like which algorithm you use. I mean, like bigger questions like eager versus lazy. Scheduling, batching. And I need to talk about this because this is getting to where the signals, proposal for TC39 is sitting, right? And you have to understand where the source of a lot of this stuff was. In the example I showed a moment ago, I showed each system in 2 modes. I showed it the mode with effects, and I showed it in the mode without effects. And it's important to see both, because effects are largely the most disagreeable part of trying to standardize on what like the meaning of signals are, because it's where a lot of the complexity comes in. But yeah, let's just talk about a world where we're all push pull in the first place. You guys have the chat, callbags equals sandbags. Are you guys talking about Cycle.js in the chat or something, or under Stoltz's work? You guys are, yeah. Don't forget to like the stream. Thank you, sir. With so many of you people here, it makes a huge difference. If you're on YouTube, you can just hit the like. How many people on Twitch? We have about 78 on Twitch, which means 270 of you roughly are on YouTube right now. So I want to see 270 likes. Callbacks are actually purely push-based. Well, I mean, and this is the whole thing, right? The push side of push-pull is purely push-based too, right? So like, there's interesting trade-offs to this, because when you have a push-pull system, you are doing 2 waves. You are pushing and then you are pulling. The other ones, either they do it in generally one pass. They either just push or they just pull. Pull has the benefit of, like, when you have crazy diamond problems, like this one is one of my favorite examples of all time. Pull, at least, that you're kind of going to go all the way through, right? Like, if you go E, what do you need? It'll go B. Like, generally pull-based systems will pull all the way through. Push, you don't know at E if D is changed. Like, you might go A, B, E and then like miss this change, and then C updates D and then run E again. Push-based systems have this kind of challenge, and I go into detail about like what that means in this article. I don't completely want to get there right now, but once you decide that you want to solve the consistency of a issue like pull does, and you want to, not do everything, like the problem, both of them have shortcomings, right? Like a push-based system only does the work it needs to because it knows exactly what's changed, but it doesn't know how it's going to be used. So its idea of what it needs to is just like anything that could be changed due to this, go do it. Pull-based system goes, I only care about the thing I'm looking at. So it's good at localizing your changes, but it has no clue in that local scope if anything's changed. So it like has to do all the work that way. Push-pull lets you scope on both sides. It goes, okay, I know everything that could have possibly changed, so I know I can disqualify a bunch of these other things to pull. But on the other hand, I'm only going to pull what I care about. So if there's other changes out there, they don't need to propagate. But that whole premise is based off laziness. And for some people who don't know this, because Solid's reactivity system long predates, it's been out there for a long time. Even though technically we are push-pull, I say Solid is more push than pull in that it always propagates out the change. So technically it has all the wastefulness of a push-based system, but it doesn't have the cycle problem because when it reads D, it actually pulls the value through. So it's like push, then it's almost more like they're all push then pull, but it's actually like push and then pull as you're pushing. It's like pull as you're pushing is the best way I can explain Solid today. Like if it gets here, goes A, then B, then gets to E, and then like because it does the two waves, like it still notifies, and then when it runs, it basically does all the work eagerly, which in some ways is seen wasteful, but there are implications of that. See, on one hand, you could argue that for most systems, the stuff that you have on screen is the stuff you have on screen, so to speak, right? Like, there's not that many computations that are sitting there that need to re-execute, that are expensive, that you're not benefiting from the re-execution because, they can be dynamic, right? Like inside derived values in Solid, you can change the dependencies on the fly. It's not like having a dependency array on the end. If there's a conditional, then while one condition is true, it's shortcutted that way, and it's not depending on those other things on the other branch. So like, who cares if you run a couple extra computeds that aren't being used initially? They're not like, aren't being used in the view. Like it comes up fairly, not very often, except for when it does. However, there's some nice benefits to being lazy, right? Because then obviously things that are never used never need to impact anything, right? So I knew with Solid 2.0 that I wanted to go to lazy, but that isn't big news because literally like preact signals are lazy. I think view signals are lazy. Pretty much everybody else's signal implementation other than Solid are actually lazy. They're all push-pull, but Solid's actually the only remaining one that's eager. It doesn't make any difference in any benchmark or anything you see because literally you only do the work you need to do. So, you're not going to hit this problem. But there are benefits to being eager when we start talking, getting into other zones, like, and in the Solid 2.0 zone. So that's why I'm bringing attention to this right now, because I just want you to understand the difference between eager and lazy push-pull, because lazy will say, I'm not going to run any of these until I get down to E, and then I'll notify down, and then when I run E, that's when I'm going to start doing the work. Where an eager one will say, I'll notify it all, and then I still kind of actually push downwards. The reason that we were eager and push downwards is because of equality checks. This is something that's actually important to understand. What if you don't want the data, like what if even though you changed A, C doesn't change, so D doesn't change, so only this side matters. It's a lot easier to do equality checks on a push-based system. Like pull-based, it's a little bit fun because you actually have to walk up things that may have not changed. So like there's a trade-off here. Things could have changed, but you're not guaranteed to know that E has changed. Whereas in a push-based system, or even a push-pull based system that's eager or more on the push side of things, you can actually, not get down to E until you've made sure that everything else is run. The second benefit for eager versus lazy is that think about when things run. If you have a lazy system down here and you have like a scheduling consideration, like React, right? In React, the effects run after render, right? If you don't hit something in the drive data until you're running the effects, these run at effect time. There's no phases. There's no like pure stage. Like in React, you do a pure render where you get a VDOM back, and then you do a real render, and then your effects run. You have a guarantee that every memoized value, computed value, whatever in your stack has run before render. And it happens at that timing. Whereas in a lazy system, those things could run depending on where they're consumed. So like there is a definite trade-off here. Yeah. They refer to it as a clock, right? And SJS was based on it. Was based on a clock, and that was where Solid originally was. And I actually have an old demo here in a code sandbox about it. The problem is, it's challenging for me is that I don't think developers expect that. The benefit of a clock is that that everything's committed at the same time. So there's no way that any future change can impact like the current propagation. It's kind of like the way React leaves set state in the past. But it's also like really, people struggle getting their head around it. Oh, sorry. You're talking about. Oh, sorry. I see what you're saying. Sorry, I was making a different point. Yeah. Well, I mean, that's an interesting question, right? No, it depends. Your effects should be the only form of actual tearing, right? So as long as you schedule your effects, push pull always schedules effects, regardless, right? That's a trade-off. But I mean, it doesn't matter because like if you have effect E, F, G, H all the way down the line here, and they read some of these same data things, they're always going to get the most up-to-date value because you pull it essentially. So it will only, the push pull just saves the recalculation, but you're always pulling at the end. What the push pull also does is it saves which of those things, maybe only E and G end up on the list. But because you're pulling in the end, tearing isn't particularly a problem. I guess an example of this would be something that someone might do in Solid right now. Have you ever used a chat? You guys are in a chat right now on Twitch or YouTube. You know exactly what I'm talking about. You know how it keeps on scrolling, right? Like you type something and it scrolls with you, right? One way to implement that is to read the DOM pre-render and then say the list changes or something. It before you render, read the DOM position there, and then after it renders, see the change and scroll it. Like basically, it's usually a two-part system. Now, if you were using a memo or computed value or whatever to read it, and then use it like a use effect or effect to do the last stage here in a lazy system, like if it was pulling the value from the memo, it wouldn't run it till after render. Do you see what I'm saying? Where it's like in Solid today, that it's very easy to just do that and have a working system. Like memo listens to on list change, gets the position before render, then after when the effect runs and it's already done the render, grab the value, and do the change. But if you move it to being lazy, you're not actually running the computed part until after render. So I don't know. I'm just you guys are all just trolling me in the chat. Yeah, okay, that's fine. Do you understand what I'm getting at? Like, you remove the guarantee that all pure calculations happen before all effectful calculations. That is like something that a lazy system has to take into consideration. It usually doesn't matter because you're guaranteed that any effectful calculation that depends on pure calculations, every pure calculation it needs will be calculated before it runs. And so like you don't have to worry about like the values being wrong, or that different effects see different values. They will all see the same value. The problem is that you no longer have this sort of definite pure phase. And this can impact stuff like suspense and transitions and concurrency. What am I bringing up? Well, okay, we'll get there in a minute. Let's keep on going. I just wanted to talk, at this point about, push-pulls added complexity. We talked about scheduling and eager versus lazy. Batching is another concern. I wrote a whole article also about this, back in the day. What was it? Consistency in UI frameworks. Let's grab this one. I'm going to drop this in here. All right. Where I ran this very simple use state, use memo, and then like click, and then inside the click, we wrote what the count is, what the double count is, and what the text currently in the node is. And if you remember, every framework had a different answer. React said 000, Vue said 120, Svelte said 100, and Solid said 122. I argued at the time that React was correct, if not in the past. It's actually pretty okay. And Solid was correct, but it was, in the present. But these two were inconsistent. Right? And it's an interesting dilemma to be in here because you're at the edge of the reactive system here, because essentially you have derived state and then you have update. And the thing is, you can see why each framework end up where it is. React was like, look, we pull when we pull. All this is some like pure part. So when React runs your code here, they've updated nothing. They're like, look, count has not updated. You called set count, but we don't update it. Double count, therefore, couldn't have run again. It doesn't update. So the text is not updated. Simple. Solid is on the other side. The second you set the count, it went and did all the work. And then when you read it, it was like, okay, yeah, count, double count, element, everyone's up to date. Perfectly in sync. Svelte was a fun one because Svelte looked at it and they're like, okay, well, in theirs, it was like count plus plus. So when they looked at it, Svelte was like, okay, so count is updated here, but double count hasn't run because it's still the closure of this, right? Like, how could double count have run on the very next line? So, and obviously we haven't updated the text yet because at the time of you calling this function, you've only updated count. Vue was like, okay, yeah, we're a reactive system. So you set count, we've updated it. And double count, we always give you the latest value. So when you read double count, well, you get the latest value as well. But we haven't scheduled our rendering yet. Each system has a logical reason for ending up where they ended up. The problem with sync, Solid's solution goes like, clearly that's the right answer, right? And a bunch of people are excited about that. Is that like, if you call set count like 10 times here, like you do 10 times the work. Vue React, and Svelte all assume some sort of implicit batching, where you get the chance to do your work before it actually impacts the DOM. React goes like, we need to be consistent, so everything's in the past. Vue goes, look, we have a reactive system. We'll always give you the latest value, but scheduling, we'll schedule the expensive work. And Svelte is like, we will follow the rules of what it looks like if you're just following JavaScript. But yeah, so like it's like, and don't ask us to explain how double count works. We have a compiler. I think that's fair to say. So the thing is, obviously, if you do fine-grained rendering like Solid does too, where you update, like, in this case, you're updating one text node, doing it a bunch of times is kind of like, who cares? Like, if you want to batch it, then batch it if you need to. But the base case is not that bad. But I think this sort of thinking is still very important to kind of understand, like, the challenges and thinking that goes into batching, right? A lot of systems that have a lazy system, essentially, because you can always ask for the latest value, tend to both be lazy and auto batching on a microtask like Vue. Basically, they almost all look like Vue. So this is kind of where we are today, where most, arguably the Signals 1.0 solution involves laziness and potentially auto batching. But this is a critical piece, which is why nobody wants to touch effects with a 10-foot pole in terms of trying to come up with a spec for this stuff. Because, like, who's to say Vue is right or Solid is right in this zone is kind of been the position frameworks are taking. What if I never want the work done? I know that sounds weird, but what if it's off screen? Like, what about suspense? What about any other kind of work which needs scheduling? Yes, React does have flush sync. Svelte and Vue have tick. Solid has batch. So technically, every framework can do the opposite operation with the right syntax. You just have to, it's what the default is. You have to call something else, right? So, but it is an interesting one, because this is one of the debates. Solid was the only system that was set up to be purely sync. But most of the places people have been going to have been async. You're right. It's very easy to just call flush sync if you want it to update immediately. But I mean, there's an interesting consequence there. That means at that point, you're going to do all the work, which is, again, what Solid's doing, which seems fine. But, like, there's a subtle difference between, say, tick in Svelte or Vue, which you use in await. It makes an async function. There's a positive to that. It means that scheduling still happens when it happens. You don't actually force any work to happen earlier. And if other things would happen afterwards, they would still get to apply if they happen before the scheduled time. The other downside, the flip side, async means that you are definitely waiting async. You lose the ability to interact with this thing synchronously, which can also have impact, on events. And, like, events are designed to work synchronously. You could probably just do all the stuff above the await, but I'm just kind of pointing out that, like, there are considerations and trade-offs between the two different APIs. Yeah, I have to admit, I don't know a single person who actually likes generators. Like, it's like this mechanical thing that solves so many problems, can model so many things, but it's like also like the ugliest. Every time I look at it, it's, yeah, I don't know. Async generators seem like hard mode. I don't know. It's just like, in some ways they're so simple because you just like go tick 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 tick, or, so to speak. You can just pull, yield, give up control flow. Like, it's just funny though. Like, have you have you ever seen a JavaScript framework that uses all generators, like their to-do MVC? Go check out crank.js and look at their to-do MVC, and then like people should come back and then see what they feel. Yes, these videos are always on YouTube, and it's streamed live on YouTube too. I leave them up. All my stuff, we get some timestamps, so yeah, you can always come back. I know this stuff can be heavy and dense. I try my best. I answer the questions, but it's all up there for longevity or whatever. Yeah, I've seen the flow abstraction. I was always confused a little bit about this, so we'll talk about it when we get to async flows a bit, because like what tracks? I almost the only time someone ever convinced me that we wanted a flow type abstraction was that they had a website where they could capture the Konami code. You know, up down down, left right, A B start. You know, the classic, you know, Contra, get 30 lives. Basically, you know, or old Ninja Turtles, like basically all the old like Nintendo games had this code. You could just enter in on the controller and get like some bonus. And he convinced me that detecting something like the Konami code in the code was actually tricky in a signals based system. There's too much like state ephemerals. It's like using a state machine. It's like an argument. And in some ways I thought the flow was a lot cleaner of an approach than say using like X state or whatever, for if this was just your problem. But outside of that, I've been having a real hard time there. Yeah. For later, you like sync model for teachability mental model. Yeah, it makes things just so much easier. I was talking to Dax, SST or whatever, and he was one of the biggest proponents of like our sync model, and he's just like, it's like when people come in and they expect stuff to work a certain way, it's so nice when it does, which almost never happens in React. So like it was like one of the fresh breaths. Like it makes you feel closer to the platform. It feels like you know what's going on, you know. For like, even though in theory might not like be completely performant, if you just go set this state and then it sets it and then you can see it, you feel good about it. Like you got to be careful taking away the developer's ability to just console log everywhere. Like this is a JavaScript developer thing maybe, but like when you do something, you want to log and you want to see that it did something. And this is what it was one of my criticisms of React Forget, actually, because I was like, how do I make sense of what executes anymore, right? If we assume that, you know, function bodies are basically pure, then you like console logging could poke a hole in the veil, so to speak. I don't know if that's true. We'll look at the article later about React Forget on This Week in JavaScript. But yeah. So anyway, I'm hoping you're feeling, you know, the tension. Yeah, see, maybe if you have a good enough abstraction, good enough dev tools. I know the Nux dev tools are great. I have not played with the Vue dev tools. I haven't even installed the solid dev tools, other than, I think, not on this machine at least. I did look at them in one because it's really cool. There's like a visualization of like when you could like basically see when you update one piece of state in like one place, you could like go, oh, and it updates this node over here. Basically like a perfect visualization of your data flow through your application. It was really cool. Anyways, I know Vue and the Vue community has amazing dev tools. It's a place I'd love to get, you know, polished, so to speak. Yeah, well, yeah. When a div is a div, thanks. This is exactly what I'm talking about. You know, you can go you in Solid, you can literally go like div JSX and see that it's a div. These are interesting things because they sometimes make your life a little bit harder, but then on the other hand, they make you feel like you're right there. I mean, Svelte is actually really good on that kind of level of abstraction where it's not quite as flexible, like being able to pass divs around like the way we do, but like on the other hand, they make you kind of feel like you're just in JavaScript land. Even like in this example, it's sometimes not what you're actually looking for classically, which is why I think they went to Svelte 5. Like people go like, that's sweet that it works like JavaScript, but I actually don't want it to work like JavaScript. I actually want to do more here. But like, I think those little wins, those little feelings of being connected have always been what made Svelte always feel so good to use. No. Okay, sorry, I should give that an actual thing. Proxies are a mechanism. Proxies are like a function call. And you go, okay, well, a proxy with an event emitter. No. Signals are a DAG. They are a directed acyclic graph. It's not about the individual tracking mechanism. It is about the data propagation. It's about the guarantees. There we go. Another shout out to the view folks. There you go. Thanks, Theo. Yeah, no, it's pretty good. I need to up my tech at some point. I keep on mentioning it, and we're like, oh yeah, we'll get to it one day. Yeah. So, oh, thank you. So yeah. So getting back to our arcing thing here. That's kind of like signals today. You go look at Preact signals, you look at view signals, you go look at quick signals, whoever else signals, Angular signals probably. Yeah, I imagine it's the same thing. But Solid already is doing more than that. And that's what View Vapor looks to aim to do and what Svelte does. And it's not just on the rendering side. We introduce a whole other graph. Everyone knows about the dependency graph, right? We teach push, pull, we talk about data dependencies. But we secretly, or not so secretly, have a second graph. And you see this in Solid's dev tools. Sorry, not to get hijacked too far over, but synthetic events were for a fairly good reason. They wanted to do event delegation, which automatically does significant performance improvement, but it's also because you got to remember when React came out, the web was way better than it was in the jQuery days, but we still needed to patch native behavior. I'm sure if you talk to them, if they could change things, they would get rid of on change or like do something, something like a bit different. But in general, they they needed to solve a gap in where browsers were at and how different events were handled. It looks really nasty now, in hindsight. It's one of my on the way on change works in React just drives me nuts. Like developers come into Solid, Preact, any other framework and like on change, and it's like no, that is not what the browser on change does. But like I can't fault them for trying to polyfill it. If you go back, Knockout had a change like base that worked like actually no, Knockout's change actually worked like normal change. They actually had like a second mode, like value change, which worked like React's change. But like my point is like there was a good reason to have to like polyfill this early days, and then they were stuck with it and couldn't change it. Anyway, this is my fear. This is my challenge. So when I talk about ownership, the coolest thing about Solid is you almost never actually see the ownership graph. We hide it under the render function, but there's this idea of roots, right? And now I can't use our simple code anymore to do this, but if you've ever seen something in Solid, you can basically like let me go cons. I'll just do. Let's just do createEffect. It's the easiest thing to do. If I go in createEffect, and everyone in React is used to returning a cleanup function, but what I'm just gonna say on cleanup console.log hi or something like that. Let's createEffect. But if I go like let's listen to count here, whatever, it doesn't matter. I need on cleanup as well. On cleanup. it's not too surprising, people, that we're going to see high. Like initially, none, because it doesn't release, but every time we rerun it, we're going to see high, right? It's the same rules with createEffect. Whenever it runs, we run on cleanup. But the thing you have to understand is this on cleanup is not specific to an effect. I could put it in create memo. I could put it in the component body here. It's specific to the reactive context. And it's funny, I've been talking to framework authors a lot, over time. People like Fabio from Voby, Alexis, obviously works on solid stuff and million stuff, but he also had his own framework, CompuState, and there's Sinuous, and there's a whole bunch of these reactive based frameworks now. They all kind of take the ownership model for granted, but it was never present until SJS and Surplus. But it's become kind of the norm, but it's not in all the VDOM implementations. You won't find it in Quick or in Preact. So this ownership model is the idea that if you put an effect in an effect, you can basically register this effect with the parent effect. So when the outer effect runs, I mean, we can just do this for fun. Let's make 2 signals and 2 buttons. Let's just double everything up. We're gonna put count 2 here, and we're just doubling it up. Count 2, set count 2, set count 2, count 2, increment 2. Button. Let's go increment 2, count 2. Okay, sweet. All right, I should change the message. I should be inner, outer, right? So as I do the inner one, you're gonna see inner clean up every time it runs. If I do click the outer one, what you're gonna see is inner run once and outer run once. See, inner, outer, inner, outer, inner, outer. So basically, like the cleanup function, createEffect automatically has a cleanup function registered in it. And it makes sense, because if you didn't do this, and old reactive systems don't, and I don't even old, even modern ones don't, they return a dispose method. You'd be sitting there managing the disposal manually of when this effect stops. But by the very nature of what we do here, we don't lose memory this way. If the outer effect reruns or is disposed of, then the inner effect is also disposed of. You don't need it anymore. And you could think about it, if the outer effect reruns, you don't want to create a new effect every time and not dispose it. It'd be a memory leak. So the base, there's ways to work around it. We have like run with owner and this whole stuff. But the base model here in Solid and renderers that copy or mimic Solid, fine-grained rendering, stuff like Svelte 5 or Vue Vapor, is this idea of being able to have kind of like a disposal unit based on being able to like nest these things, because that's basically how we do our fine-grained rendering. Yeah. Yeah, kind of. Yeah, like that's how our renderer. How do you think we get like such fine-grained rendering working? It's not just effects; it can be memos too. But like think about show like conditional statements and stuff, and inside them they create DOM nodes that also have effects in them that render certain elements and stuff. Like this is the secret to fine-grained rendering. The decision points where you choose to listen to is where it marks, essentially. So if only count 2 updates, then you don't count 1 can stay the same. If count 2 updates, then it's possible that there's a decision. Like if count is bigger than 5, like we can do stuff like this, right? We can go, what if we said like, if count is bigger than 5, then create the effect and register. Yeah, let's do that. Right? Now, the interesting thing is this inner effect doesn't exist at this point. But when I bring this one up, see outer, 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 outer. Oh, inner, inner, outer, inner, outer, inner, outer. Essentially, we can bisect our whole app by using a whole React graph. This is when I say reactivity is all we need from solid standpoint. It's that we have this automatic ownership model. This is what SJS and Surplus gave us. This model that is smart enough to be able to handle hierarchies, right? Not every reactive framework has this. That's why I'm calling this React Signals 1.5 in a sense, because this is the piece that enables fine-grained rendering. It can. The challenge is it does. What's interesting here is that why do you make a new effect here? Why do you nest an effect? What is like, because actually with this count here, we don't need this count here, right, anymore. It's generally this. It's because there's a decision to be made, right? So it's not because there's a component boundary. We don't care about component boundaries. We might as well just be function call. It's because there's a decision point. If there is no decision, if your HTML shape is completely static, then there's no need to nest the reactivity because everything would be present at the beginning that's present at the end. That's simple fine-grained stuff, like Preact signals updating a text node in the React implementation or whatever. But if we were talking about conditionals and for loops and structural stuff, then there is this desire to have these contexts. It's not component based. It's not based on what the end user authors, it's like directly like how they want to break up their code. It's based on the actual decision points in your actual app, right? We don't need a compiler to analyze them. You do write them, the end user. You go, yeah, there's a condition here or there's a loop here, but that's the context. We don't need a new context per every component. You can break into a billion components. We need a context per structural decision point in your app. Right? So in a sense, it's not a particular view or a particular component, but it definitely mirrors that. It's just it's kind of like the largest scope of decision. Yeah. It creates multiple because, yeah. The thing is, we were able to hide the main root. It's in here. It's in render. One of the funniest things that people don't always realize about Solid. I'm going to break this for 2 seconds just to show you what I'm talking about. But if I go like this and I make these into capital button, okay? Now there is no capital button, but if I look at the output code, you're going to notice something kind of funny here. There is no, other than this render call here, which is called document create element. So if we made this into create root, essentially, there's no DOM APIs anywhere to be found here. None of this is DOM. The only thing that, like here, this create component call just calls your button component, which I haven't implemented. But my point is, people kind of misinterpret us as being tied to the DOM. Not really. Like the lowercase JSX becomes DOM elements because it's convenient. But generally speaking, the rest of this is a tree, essentially. It's not a virtual DOM tree. It's not based on your view size so much. I mean, I guess this is based on the size of the number of components you have. But like, if I go back now and do this, you'll see that we've hoisted the templates out, so to speak, so that the actual size it's based on the intersection points, like adding click handler and inserting children dynamically, adding click handler. Like, it is a tree. It's just not a virtual DOM, and it's not done even like, there's 3 types of rendering in web frameworks, generally speaking. There's this fine-grained, which just updates as much as it can based on the reactivity. Like it tries to get as small as possible based on tracking. There's single pass diffing or dirty checking, popularized by Angular, used by Lit, used by most lightweight frameworks, Svelte before version 5. And then there's VDOM, which is churn out the 2 pass, generate the stuff in a virtual way, and then diff it on the second pass to update the actual DOM. But both the latter 2 ways I just mentioned involve doing this kind of diffing pass based on some kind of unit, like a component or some kind of thing that's defined, by the way you break up your code. Whereas the reactive approach here is based on based on data flow. So like the breakpoints are based on the conditions of rendering or whatever. It's not based on components. Anyway, but yeah, the main root is hidden in here. If you look at render function, if I go to solid.js code, you'll just see that it basically just it wraps create root insert into document whatever you pass here, but it's basically just a create root call. Yes. Yes. Let me see if I think it's at the end of this article. It's an older one. Yeah, here. Interesting how Solid takes this and makes full rendering library out of it. Check out Solid.js reactivity to rendering. I wrote this article a long time ago. Hopefully the Angular people at In-Depth have not taken it down. This is an Angular. These guys, it's funny, the Angular community was very helpful early days because I'd write like these huge, like 20-minute read articles and they would post them. This one isn't in my Medium, isn't in my Dev 2. I explain how to build a solid-like renderer from scratch. Yeah, it's a tree of extracted. These practically tend to align with extracted templates. Well, right, because you can only merge a template as far as there's a decision point, right? Because otherwise it would be static. Like if you could go through and extract all, like if there was no decision points, your template would just be one large blob. So yeah, I guess that's fair to say. That's said quite elegantly. Yes, yeah, and that's what I'm saying. We already have native solutions, not React Native. And but we have universal renderers. We have solid TWIJS. We have solid ink and PDF and all the like all of those things. You don't need a virtual DOM to do that stuff. This is part of why we had to go so long to get back to the fundamentals. In the process, we built everything. Everything you can do in React, with the exception. Well, I'm not going to say with the exception, because like we prototyped it, but we didn't release it. Everything you can do in React, you can do in Solid. I was talking about RSCs. We never released our server component solution, but like you can do everything you can do with my whole premise theory behind thing is everything that can be done with a diff can be done without a diff more efficiently. That's like the guiding principle here. Whether that developer experience is, aligns with your expectation is another question. But, and there's a few hard problems we haven't solved, like state preservation in HMR. It's actually kind of trickier with fine-grained systems, but it is my belief that anything that can be solved with a diff can be solved more optimally without a diff. We have a solid. Yeah, is it solid ink? We have the CLI like port. It's the funniest thing about this too, and people don't realize it's been a few years, and part of it is because Nikhil Saraf is like the man, so to speak. Like he can just prototype and hack out stuff like at a rate no one can match. The first week he joined Solid, he used Solid, he made 3 libraries. He didn't maintain them. Don't go me. It's way easier to make a library than maintain them. But he made a solid CLI, solid PDF renderer, and solid 3 fiber port. He just went in and hadn't used it before, and he just was like, here, you guys have a community thing, and we're like, come demo it. So it's definitely doable. A lot of people assume because of the rhetoric that surrounded React when it first came out that you can't do these things without virtual DOMs, right? And it's simply just not true. What are you using for CLI terminal rendering? Anyway, did I share this article? I put it up on the screen. Yeah, I shared it. Good. Okay. We're not going to get too much into it today, but I actually kind of prototyped like how like even a for component, talk about reactive roots. I've never given this topic a good enough refresher, I have to admit. But I mean, that's the problem, or that's the thing. That's where we are today, right? We're at a situation now where when we talk about it, I think the ownership graph is really powerful. We talked about disposal, right, and cleanup, right, nested things, but it's also how Solid's context API works. When you use context and provide context, we didn't invent another thing. We already know this, right? So if you set some context and make a node here, we just walk up the reactivity graph because we can't use other methods. We don't have artifacts like a VDOM. It actually took me a while. This is one of the things that I think Solid did first out of like SJS didn't have this. One of the changes we made was I was trying to figure out how to do context, and it was actually tricky because you don't want to rely on the realized DOM tree. That's one way of doing it. That's how like the web component context spec works. That's how I've done it with Solid components. That's how I do it with islands. But you're creating stuff here before it's even inserted in the DOM. So the timing's wrong. You want context to be available synchronously at render time. But you also have like no VDOM nodes, or like what are you tracing? Like the functions are just functions. There's no output. Like what are you walking up? And I realized that the same nesting of the reactivity graph essentially could use context. So you don't need, even though our APIs are all DOM based, there's a reason. You want the context provider, you don't want it to like compete with each other. You want it to be like, there's a reason. Like I think Dan had an article about this a while ago, Dan Abramoff, and he was like, why is it not use provider? Why do we make you use a component for it, right? These kind of fundamental decisions are important because if you make someone use a component, they have to wrap it, right? There's no way, like, there's no misunderstanding. There's only one provider of this type here. Like, if you had it use provider, someone in a different sibling could just be like use provider, and you can all override each other or like mess with it. This API forces it. I've always loved React's attention to detail than that. They just don't just follow a pattern because the pattern exists. But technically speaking for us, even though we're doing JSX, it is actually a reactivity feature from the ownership graph. What are we paying not to be DOM definition? Should be some tradeoffs. Well, I mean, classically, it was memory, but then the VDOM also creates a lot of temporary artifacts. Reactivity, the memory overhead used to be considerable consideration. There's like, if something over executes here, we're creating real DOM elements. Like React's worst case is better than our worst case. But sometimes our worst case is so much worse that people notice it sooner. Like if you're doing something really dumb, like you'll notice it immediately, where React will just slowly kind of creep out of your control. You can lose reactivity. We've seen this. I think this is the thing, where people like aren't using this model, like they're not thinking the right way. They can lose reactivity. React always just does all the work anyway. So same sort of optimizations don't make sense for them. So it's like these are things like for me and a lot of Solid users, like the trade-offs are like not even close. But like there are definitely there are differences. Here's a question: include Solid in his router. because he couldn't make it perform. Like React's model and Solid's model were opposite to the point that if you try and force, yeah, I mean, this is actually a prime example of your previous question, because the problem was most of the time when I get a React library and we bring it to Solid, we have to do this diffing, and we have a data diffing thing called reconcile in our stores, and it works fine. But it always pains me a little bit. Like obviously, if you're sending something across a wire, you don't have any referential things, so like async stuff, you're generally going to diff. But it always bugged me that anything that was like deeply in the client, why are you diffing when you don't need to? And it occurred to me, like it would be really cool if we actually had fine-grained updates in the router. But the challenge for Tanner was that we did that, we implemented it, and it worked lovely in Solid, and it was fine. But on the React side, they had no way to interact with that. Like, so I guess maybe there's an interoperability story, right? Like if you need to be using signals and fully leveraged signals like reverse it, like they only execute as much as needed, whereas in immutable data structures do the change at the root and they clone all the way up. So at the root, you can very easily in a immutable setup like React be like, run this if this changes. So you check, you do memo, you rerun the code anyways, but then you get there and you go, okay, do I do the work? And you go, has this changed? Or anything below it. A reactive system doesn't do that. A reactive system goes, I will change when at the point that I change at. So you can't easily be like, oh, tell me if something this or everything below it changed. That's like, it's anti the pattern. You don't want to run when the stuff below it changes. It will handle itself. But when you're trying to interface with React, which doesn't understand that, like you have to make the use thing, and that has to be your point of change, where like a deep fine-grained system won't actually notify because it will go, oh, actually only this one field changed way down here. React somehow has to now listen to all the potential fields, below that point of change. Whereas a reactive system would be like just more optimal and just be like, okay, change, done. So it's like, it didn't sit quite right trying to do both. And then you were forced to do, like, it wasn't just detecting the change, you'd have to also propagate in a way that React understood. So even if we realize it changed, then you'd have to like give it an immutable data structure. So like every other part of the React rendering could diff, because the next thing might be like, oh, has this changed? Because that's what React does. Like as it renders, it goes, has this changed? Has this changed? Has this changed? It just keeps asking that same question over and over and over and over and over again. So we're like trying to force a system that's just like, I know exactly what happens, just update it, into a system that's like asking that diff question, have I changed, have I changed, was not performed enough for React. Like we were hoping that like React would just make do, people using React are used to not having performant things, but it was a little bit too much. What's your thoughts on incremental LOM? It's a dirty checking. It's a single pass diff, basically. As I said, you can basically put everything into 3 categories, right? I'm on the fine grained side. Incremental DOM is a single pass VDOM or dirty checking, and then other VDOMs are 2 pass. Yeah. I mean, to be fair, like I didn't say it originally. I'm gonna attribute that to the other person working on the TANstack router solution at the time with me, who's usually a lot more vocal about that kind of stuff. Losing reactivity? Sure. 2 seconds. I can show you losing reactivity right now. What if instead of going count 5 here, I go count 5 and I go, or let's go number 5, and then I go const number equals count. Now I've just completely killed this. You won't see any effects run because this never updates, because you reference the signal outside of the effect. The component doesn't rerun. It's not a tracking context. So That's how you lose reactivity. If you access the value in a place it's not listening. Yeah. Anyway, let's keep on going. So ownership model, disposal, context, error boundaries, right? Because again, these are kind of view-based concerns. What ownership, like what Daniel was getting at earlier, like ownership considerations are kind of view-based considerations or hierarchical. Like you care about error boundaries because they are a section of your app, right? Because like you want to go, okay, something errored down here. I can't show it consistently. I'm going to just bail out and show something else and tell people they need to try again. But again, we can use the reactive system nesting as a way of setting owner boundaries, like error boundaries. Because error boundaries, what are they? But like another way of doing a conditional. They're an if statement, right? They're another way of saying like show this or show this. What's another one? Suspense. Show this or show this. All these mechanisms were built off the reactive context instead of the component context, which is why in Solid, there's that tweet I think I showed the other week. Let's see if I got on my bookmark still. Where I'm not gonna find it right now. Oh yeah. Where someone showed this example, and let me get a big screen for you, where the first thing that everyone some people notice is like, why do you need a separate component for suspense and react, right? Why does suspense out here and why is the status component over here? Like, yeah, this is really nice using use, but why isn't this all in one component? Well, the reason is because React works at a component basis. So because we work at a control boundary basis in Solid, you could literally just take this code and stick it up, like put the anchor tag in the suspense boundary, put our use resource or whatever above, and the suspense can be nested because it happens at the control flow level. We don't need to separate components to do things like suspense or error boundaries. It's just another component, right? So this is why ownership is powerful, so to speak, right? There's so many use cases where we needed a construct, you could say, and where React has its components, we could just leverage the already existing nesting of reactivity. So in another way, while this ownership graph is another graph, it means that when I create this effect here, right? This effect keeps track of all the effects that are created under it and releases them when it reruns, the same way it releases dependencies. It does have this incredible power of being able to simulate all the hierarchical stuff without adding another structure. We don't need to add another representation. We don't need to take up more memory for another representation of this data. It's all the same thing. As you can start seeing, these are just little bits of improvement that actually take care of that overhead and remove the classic trade-offs of using this approach. Because signals, again, I've said this a billion times, it's not like you add signals and suddenly you think it's faster. It's that you are able to remove something else that was making your system slower. Signals, adding anything to a system, adding signal system will make it slower. Like look at the pre-act benchmarks. Adding signals to pre-act make it slower. But it's what you can get rid of once you embrace the approach, which is why, as I said, I call this maybe signals 1.5. Yes, ownership is a tree. You're absolutely right. It's not even really a graph or anything. There's only a single owner kind of consideration. There's places where we hop, like a for loop. You don't want to, every time you do a for loop, you don't want to release all the elements above. So we actually hoist the ownership a level above. So the creator of the for actually owns it, and we independently release individual elements. But it's still, you only have a single owner. So yes, it is definitely just a straight tree. Control boundary is any decision point in your app. Like If this was your app here, your whole app, essentially, there's no decision point except arguably where you insert this text. But if this piece was, and I'm going to use React syntax to make React developers more familiar, if this was like count is bigger than 5 or something, then I'm just going to and it, whatever. Now there's a decision point because now there's a control flow. Like now this may show or may not. And right now it's just a button, but it could also be a whole section of your app. And inside that app, there could be more decision points. But it doesn't matter how many components there are. It matters how many decision points there are. And you can see it. You wrote the decision point right here. You go like if count equals 5. It's not hard to picture what the output of this compiled is. It's a little bit optimized because we do a bunch of memoized stuff. But you can actually see that it's actually wrapping a memo around this create count bigger than 5, and then it inserts your expression. Like this is where the decision point happens. And that's what I mean by control boundaries. So like you could put a suspense thing here. It doesn't matter. Components don't matter. Anyway, let's keep going because we're at almost 2 hours here, and we're only at signals 1.5. So we've been able to do a whole lot with even with our eager approach to building up incredible patterns here, right? We can handle, suspense, concurrent rendering, transitions on top of this pattern. But there's like rough edges, so to speak, that I feel like could be improved. There's places where, eager evaluation isn't great. Like resumability. You don't want eager evaluation for resumability. You only want to run the code when you need it, right? So like all of this stuff because we're dealing with primitives, can obviously just keep on getting built on top of itself. But there's a real question of like taking what we've learned and trying to apply that in a way that just streamlines this a lot. Signals are observables. Me and Ben Lesh have had like long conversations, or signals are behavior subjects or something, but that doesn't carry the graph implications of this. Like signals mean more than just the event emitter. They mean the actual graph that comes with it. Yeah. From my experience using proxies, quite slow. Is it noticeable when the solid uses proxy projects as I know? Is this a solution for it? We actually try to avoid proxies as much as possible. Our stores use proxies, but our props are actually getters rather than proxies, unless you use dynamic shapes like spreads. We have to make sure that spreads work, obviously. Okay. But like, we actually use getters in most cases, and by that I mean like it's like object get. Like, I guess I could let me just again for sake of fun, we'll just do this, and then I need to make this something that would possibly be. Yeah, I'm just gonna call it like that. If I look here, what you're gonna see is get on click return thing, or yeah, get children return count. Like we generally use getters instead of proxies. But yeah, you can see the difference actually. JS framework benchmark, the proxy version of Solid is actually in here, and it is slower, because like Solid's here, right? 1.08, and then the proxy version is right here at 1.14. So that's like 0.06 slower on the chart, which makes the proxy version almost as slow as lit. And getting towards, sorry, I gotta scroll a bit. God. Trying to scroll till I see something I'm familiar with. Yeah. View. And some, I guess, optimal no zone angular. Basically, I wouldn't be too worried about proxies here. Okay, there's angular signals here. So sometimes like the overhead of like proxies compared to the overhead of the rendering is probably not going to kill you. Okay. Is that example done with proxies? Svelte 5 uses proxies for deep reactivity, but if I'd be interested to know if it was. My guess is the benchmark hasn't been updated. Yeah. That's my guess. We'll see. When Svelte 5 comes out, I suspect that the switch to proxies will slow it down considerably. Not much, like 0.05. Right, and they create proxies lazily. Yeah. I mean that could also be the situation. Yeah. There's no proxies are enough of an overhead that I'm pretty confident that you'll see a bit. Could there be? Well, then it can't be dynamic. Like if you knew the shape would never change, what Vue knows all about this because they used to have this thing where you'd actually call a special API to add properties. No one wants to go there again. Right? Like if you know the shape won't change, it's fine. But like if you're talking about deeply nested stuff, yeah, like in checks, yeah. Yeah. And we actually pretty smart in our heuristics. Like we even can tell in certain types of spreads where we don't actually need to be dynamic. Like we actually do a lot of checks. Like if we can tell that all the sources aren't proxies either, then we know that we don't need to have proxies because then we know the shape doesn't change. So this was something I did for mobile. There's a bunch of people who are using low end devices and they're like, is it possible to use solid without proxies? And I was like, not today, because in certain cases, but basically, I figured out a way that, with the exception of them passing function calls to spreads, if they don't create any proxies themselves, solid won't create any additional proxies. So it is possible. Yeah, we really look like that's the level of performance optimization we look at. Anyway. All right. Sorry. So when I talk about signals 2.0, what am I talking about? Well, I'm going to actually talk. There's a few sources here that I think are worth looking at. I'm just see if I can look at my notes. There should be there's pages of them here. It's actually a solid 2.0 thing, but that's not what I'm looking for. I actually might have not written this out as nicely as I'd want. I'm just double checking really quickly. Do I have a future of reactivity design doc? Yeah. Yeah. This document I've shared it and talked about before on stream, but it's worth refreshing on. This was just like me roughly talking about stuff. Yeah. I was working on what the next JS framework benchmark should look like. I'd been working with Misco a while ago, and he came up with an example, but I mean that's a whole other topic. But yeah, I have an idea of what benchmark I want to see. So high level, high level, there's two topics that I think are rough, that I think need to be improved, moving into what I call Signals 2.0. And these are fundamental enough that they have to be approached at the core level. I'm already assuming that there's an ownership model, right? Because that's how we got to where we are. As I said, it's like you just watch the slope where frameworks kind of start where, maybe without signals, and then they add them kind of inefficiently. And then they add a few optimizations in their current model, stuff like that's where I kind of consider stuff like Preact is at. And then they go, okay, I need to get to the next level. So then they add ownership, and then they add this ability to do fine-grained rendering, stuff like View Vapor, Salt 5. Okay, now we're kind of caught up to where Solid is. So like there's a few, right? But then the next thing is, and I think people are starting to see, is that signals are also the thing that unlock resumability and solving hydration based problems as well. Like that's one zone that they improve. There's several like different applications. We saw performance and rendering. I went over this all last stream after the big long thread with Adam. I actually saw something similar on Reddit in solid form. Someone was like, now that everybody has signals, what are you going to do? Niche whatever. And it's like, no, this picture, if we had those 10 years back that everyone spent working on React to work on what you can do with data flow, like what you could do if you had knowledge of how data work through your app using signals and stuff like that, we'd be in a very different place. We have years of stuff to kind of work through, and I'm just kind of pointing out what I think where the next couple steps are. And for me, it comes down to async and it comes down to concurrency. These are places that I think, which basically just boils down to async, I guess. These are places that I think are valuable enough that we need the core primitives to kind of handle nicer. And if anyone's used Solid 1.0, they've used createResource, which is basically like building TanStack query right into the framework. Like not all the caching capabilities, but like essentially you just go like, I probably, if I go to www.solidjs.com, not the blog, I go to the tutorial and I pick a tutorial on resources. I mean, let's replace this solve. It's pretty straightforward. You're literally just like this is fetching from an API, from the Star Wars API, and you just go create resource, set the source, call the fetch call, and then like you're done. It even has a loading state indicator. This TWIJS works with suspense. It enables out of order streaming on the server. It handles automatic serialization across the wire. Basically, you don't have to worry about anything. You just go like use this, wrap some suspense around, call it a day. Right? So this seems good, but there's shortcomings in our approach today that I think have to be handled, because the first shortcoming here is this user can be null at the beginning, right? So if instead we wanted to get user.name here, let's just edit this right here. Let's say we only cared about user.name, and I put this here. It's gonna error out because user.name is not defined or whatever. Let's see if I can do this. There's an error here in the console. If I put a question mark, well, now we're back in business and we'll just see the name as we go. But my point is this mechanism, there's no suspense involved here or anything, but even adding suspense doesn't change this. It's because we can just continue picking up rendering where we left off. There was like, we're only re-rendering this one text cell here in this pre. So like, and this one because the user loading state changes. But my point is we're not rewriting a component or doing anything else. That like, essentially you are stuck doing the null checks yourself, right? How would I compare to Quick 2.0? Quick 2.0 is they're still working on speeding up serialization format optimization, which is a great thing because it'll improve the performance of the resumability in terms of like initial page render cost. But we're kind of, this is a much more fundamentals thing we're looking at here. But this is the thing is React. I often like make a kind of, you know, thing about like the you wouldn't even be able to do this in React because like you'd okay, let's pretend there was a suspense boundary. Let's put a suspense boundary in here. Let's just go suspense, right? Go suspense. Let's put suspense boundary in here. Okay. Let's go fallback equals loading. Let's get rid of this and let's put suspense here. Okay, suspense. Yay. And hopefully, okay, you see that loading. Hopefully that's updated. Let's refresh. Did this work? Yeah. Okay. Loading, whatever. Okay. Because it's actually pulling it away before it was actually keeping it there. So now we have suspense fallback. And actually, let's put like this, just like the sanity check. It's their new one. Yeah, it is. Okay. What I'm trying to get at here is because instead of having create resource or whatever, they would have use, and use is basically like a wait. It's blocking, right? They throw, and then when the component's done, it re-renders the whole component. Whereas in our case, we just care about this read, and funnily enough, this same pre is probably getting inserted and uninserted, but the user name is what's changing. So yeah, you basically wrap a lot of stuff in shows because like what happens when you have like 10 fields? At a certain point, you're just like, I don't want to check this every single place. I want to, you end up writing show components. Wait for this week in JavaScript. But like, I think that async, and this is also important for resumability too. Like this is why I've been talking a lot with Misco about this too, because in their case, sometimes like these computations haven't even loaded yet, right? Like this piece of code hasn't loaded yet. So how can you handle the stuff where you don't have to like aggressively guard and block everywhere? Yeah, sorry. Yeah, it's the other way around. Put a show inside each suspense. Yeah, it's the other way around. Yeah. Yes. Yeah, yes. With Vue, I don't have this problem null checking every part of the data, but I use VF and VL. Oh, well, yes. That's exactly the problem. But using VF or VLs or using show component, they're the same idea. It means that from that point, like pretend there's some other stuff in here. You know, I'm just making up. Like pretend there's like you're basically blocking at that point. Wouldn't it be way better if like because you know we don't run components, we just use getters. Wouldn't it be cool if you could create a resource down here and have it pass the user like pretend this isn't actually pretend this is pre, and it can render its stuff, and you could basically fine grain go all the way down the tree to the point where this is actually used and not worry about the null check, not block it right at the root with a VF or a show component. Actually do all the work up front that you can, and then just update the pieces fine grained where they come in. Right? Well, that's what we should do. It's that simple, right? Well, this is because this is not React. Suspense just uses context. reason React does is because it literally throws. It throws away everything you do here. When it gets here, it goes, okay, first of all, you have to use it here. And then it goes, oh, I'm going to throw away everything. We don't have to throw away the first time you read something. We can render your whole page off screen and then just update the pieces as the data comes in. Right? So how do we do this? Well, async generators to the rescue, right? Is this what we've been waiting for? You guys can all come out of the woodwork and do that. And that's, yeah, I mean, wait and use both have the same problem. Use is a bit better because it doesn't have to block. It's not like now we can't do anything else. Like React has the ability to control things a little bit. Yeah, you're still here. No, I'm a little bit. I'm not completely serious, right? I'm not suggesting async generators. But what we do want, I realize conceptually, is we want a bit of both. We want our component, our ownership tree, to be non-blocking as possible. You can't. At a certain point, you're going to hit something where you need the data and it's going to depend on it. But you don't want the end user's authoring experience to do that. We actually have some other challenges in Solid, right? Because what if I need to make a memo on this? If I go const username, right? And I go user.name. Now, this, actually, let's do this. Let's go back to our little pre, okay? Back to our little pre, okay? Because if I go here and I go username, and then I go like this, I mean, clearly it works, right? But, yeah, it's hard for me to show. If I make this a create memo, like an actual reactive primitive, and not just like reading inside, you're not going to see it here probably. I need to wrap the whole. Fine. Let's just do this. I'll show you what I'm talking about. Let's put a suspense component around the whole thing. I'm going to go app suspense. I'm going to go only initial. This is what we want here, right? But, oh, no, we're hitting only initial every freaking time, right? Watch me. Get rid of the create memo. Oh, this is good. This is loading. It's because the second you read this in a reactive context, the way Solid is right now, is it triggers the suspense above because you've now read it in that context using the ownership tree, right? Whereas here you're reading it under this suspense. But here, when I make this a memo, it's not just a function that gets run lazily here. It's being under this context. This is a flaw in Solid's design right now, from my perspective. It forces you that in some cases you end up doing what React does, right? Like now you're making another component, right? Like, so at our worst case here, we get as bad as React. And that's something I want to avoid. So these are part of the same kind of problem. It's because this guy doesn't know, like this guy might not know that it's reading from an async value. Having that color your graph makes things really difficult. We can get to this, but the answer is don't. It's derive and mutate the derived value. You don't actually, you want this, the createResource is basically an async memo. It's basically derived data, derived from an async source. If you want to mutate it, you need to, we don't have createWritable yet, but you want to mutate the layer on top of it. You don't want to mutate it. Otherwise, you have two conflicting sources of truth. This is actually one of the biggest reasons why I create async, is a so much better design than createResource because we remove the ability to mutate. But we'll get there. Yeah. Okay, we'll get there. But what I'm trying to show here is that these are kind of related problems, because essentially we're just using the context that it's being read at. It's not enough for our async solution because we're null checking and we are doing that. So we kind of want the ability for this asynchronicity to go through the graph and only impact where it's finally being used, right? Like reading it here shouldn't cause this to suspend. It should cause this to suspend. The other problem is, why are we doing these null checks? So what I proposed is, what if reading an async resource or whatever throws when it's not ready? I know it's React, but it doesn't throw along the component view graph because I'm not reading it here, right? I'm reading it I'm reading it here, or I'm reading it, even with create memo here, I'm reading it here. So it goes, I want to throw along the dependency graph. So if something derives from it and it's not ready, and something reads it, it would go read this, try to read this, realize that it's async, and essentially stop here automatically without you needing a null check. It will throw at this point. But it won't throw away the component. It will only throw up to this binding where it is, at which point everything else just keeps on going like it always has. And when it resumes, continues, propagates, then it will run the computation again, but it won't necessarily have to rerun the whole component. No, it wouldn't stop siblings, because these are if you've ever looked at what solid compiles to, these are separate expressions. If there's another sibling here that was something else, right? It's kind of a combination of both things. Instead of blocking it's fine-grained blocking. It's the best way to put it. It takes the best parts of React's model of not needing the null check, but then it doesn't interrupt the rendering of components, because think about it, you're only ever reading it in one of these syncs, where you're whether it's a createRenderEffect, or reading it in one of these in this DOM element or whatever. We can continue to just go, oh, we can't insert the children yet, trigger suspense to tell it to do its thing, but we can just keep on rendering it. You're getting there. What if? Does it break the dependency tracking? Because you know that this tracks. When you get to user, it goes, oh, I am listening to this, and I throw. So it only tracks as far as the first thing that throws. I'm glad you're on the right thinking. If it tracks as far as the first thing throws, it's like any conditional, right? How you can have a create memo and you can have an if statement, and if you go down one branch versus another branch, you can depend on different things. But it doesn't matter. This is one of those old examples. I think I have it in my where is it? Just a refresher for people, because we didn't go here. But the first name, last name problem. Yeah, this one, right? Where you have a first name and last name, and then you have the choice of showing a full name, right? And then, yeah, okay. So I'm making full name a derivation here. What I'm getting at is if full name is off, and is this the right one? No, where is it? Yeah, I think this is the right one. I'm trying to find where there should be a third signal that's like show full name. Where is it? Yeah, here it is. Yeah, sorry, wrong example. Show full name, set show full name. If in this example, you have a first name, last name, and then you have a toggle to show, and then a display name that's based on either you just show the first name or you show first name and last name. If display name, show full name is false, so I'm going to set it to false here, and you change the last name, nothing runs because nothing is listening to last name because you're only listening to first name, right? So, and some people, I remember, was it Michael Jackson or Ryan Florence? One of them was using solid, and once they realized this property, they got like really scared or, you know. But if you think about it, it's as long as the condition is reactive, it is basically impossible for this to bite you, because it's only like when you change this condition that last name could ever become a dependency, and then you'll run the work then. Like as long as this is reactive, and it's the same thing with what I'm talking about. Where I was talking about here, sorry, is that like as long as this is reactive and it's a decision point and it throws, as long as it won't run anything until it gets to the next like thing, but that's fine. There's a trade-off here. You'll see it in a second. Yeah, I mean, some people like but the thing is, with async, you're already there anyways, right? Because you do part of the work and then you come back and you do the rest of the work. No. We don't need concurrency or parallelism. This is pure signals. What I'm trying to get at here is there is a problem, though. The basic cases like this, you're not going to have a problem because it will just continue its work, here. So we unblock the big stuff and then we block the little stuff, so to speak. Because now, this is wrapped in a getter if it's a component. We push all the work down to the leaves, and we don't, and we have, we basically don't have to null check anymore. There is a downside here, though, and that is that what if you're listening to two async sources, right? I told you this is basically a derived state, right? Like whenever user ID changes, derived async fetch user. If memos are lazy, does that mean we don't fetch until the first time we hit this? Yeah, but no. Sorry, Dave, I don't think you're following me. We already isolate the expressions. We don't run anything again. We're like, okay, here. We run like, let's here. It's so hard because these examples are so hard. Okay, easy. Actually, you know what? Let me really spell this out. Let me go text content equals this, because attributes are more visible here. I'm just going to use text content instead of okay. When we have an element here like this button that has text count and that is count times 2, we wrap that update in its own effect. So if this count was async and it threw, like I mean, effect's a bad we essentially can just like we don't lose like all the rest of this just continues to, you know, render. It doesn't get rerun again. We only need to rerun this function. All the signals, and one of them is async. Well, yeah. So what will happen? So you're kind of going down the chain. It will stop evaluation at the first async one. So you didn't actually do the work in the first place. But you're right. I mean, you're offloading the work until the async's done. So like when it got to the first one, because it depends on it, right? When it got to the first piece, you know, let's say that the really expensive client-side evaluation depends on this async data, and it happens after. When it got to the async, it stopped. And then when it reran, yes, the stuff before the async would run again. But I mean, this is an interesting question, right? Because it pushes you into wrapping stuff independently. So what your concern is if the expensive computation is before you do the async, and then you put that in like in the create async call instead of putting it in a memo before the create async call. Right? Does that make sense? Like, I see what you're getting at, because what you're saying is like, what if, like right now this is just like user ID, right? But what if it's like, you know, sorry, do this. What if it's, let's go return. What if it's like do expensive stuff, then then do it, and then it hits this, it's async, and then it has to do the expensive stuff again when it gets to this point. Usually, at least in my experience, the expensive stuff happens after, but even if the expensive stuff was before, the answer is const expensive stuff equals create memo expensive, right? Expensive. You know what I mean? Like, okay. Yeah. Yeah, I mean, any model that's gonna like, well, is it a problem in the current model? No, not so much, because you're not going to run the stuff up to the async again, essentially. Is the affordable stuff. But yeah, I mean, you start to see. I mean, this is why I'm putting it out there, because it's not without some considerations. A big one for me, as I mentioned before, is you can recreate the diamond problem, right? Because pretend this is async and this is async, right? And E depends on it. If it reads B and throws, and it's lazy, then C doesn't know it gets read. Making async stuff lazy in general is a tricky thing to go with. So this suggests to me, at minimum, some things you probably don't want to be lazy. I mean, there's a trade-off there, right? If your async fetching isn't lazy, it means that even if this isn't connected or like on screen, you're going to be still data fetching it in the background. But on the positive, you want to make sure that B, if these are both async, are both queued, so you don't have a waterfall here. Like, you're not waiting for B to finish before C does implicitly. So that's why I'm proposing create async, why I'm not just using every create memo. Like, you could see a future where create memo could just work like this, because, you know, it gets a promise, does the thing. But I actually think the starting point of the async, where you accept the promise, needs to run eagerly if you want to solve the diamond problem. waterfalls are the most important thing to avoid if possible. Like these are things that just instantly double the time for no real reason. And now you're getting to the other side of it, right? Because sure, we can have our createAsync primitive, and if anyone's seen what I've proposed here, it's if you've seen Solid Router, it looks more like this. Get rid of expensive here for now. It's more like this, right? Where you basically just have a single thing. Reactive tracking, return the promise. But sorry. I'm trying to get back to the point I was getting at. There is still this challenge here that even if you preemptively do the stuff, you don't like, how does suspense work in this model? How do you make sure to, not run all the end user effects, right? And what that comes down to, is where I had in here what I considered the ability to control flushing boundaries. Essentially, it's kind of like the ownership idea, but the idea that you could basically have things that flush together, whether that's suspense or not. And yes, if you hit during rendering, if you hit any of these things, hold the end user effects. Now, we still have a problem here. How about if you're halfway through rendering and you hit this thing? Well, something that Solid does today is that we call render effects immediately, and then afterwards we schedule them at the same time as like after the first run as like same time as user effects. Essentially, they run before, but they schedule like afterwards, so they also get held. Like if you're in a suspense state, like we've detected async. But I think one of the easiest solutions to this kind of zone is have render effects split the pure from the effectful part. It's kind of funny. It's like the opposite of, like, I just showed you how we're trying to change createResource into something simpler, like get rid of that, like just like that, essentially, with createAsync. I'm suggesting that render effects should be a pure part and an effectful part. That way you can run the pure part, the dependencies for rendering, as many times as you want, and this comes to concurrency in play, before running the actual rendering effects. So here is where you catch all the async stuff, that dependencies. And then if it doesn't pass that, you're free to run this, as many times as necessary as async pieces kind of come in, with fine-grained notification. But then when the effects are ready, like, so all the async stuff's done, then you can go run these effects before the end user effects. This being kind of like the split between the effect zone and the pure zone. Remember I mentioned earlier that problem of when you go lazy, you no longer have guarantees of the computations happening during the pure phase. How do you solve that scrolling problem? One way of solving that scrolling problem would be to use a render effect, where you can measure, because everything that happens in the pure side half of the render effect happens before rendering, and then end user effect, or typical create effect would happen after rendering. So you'd have that guarantee of always measuring before and getting it after, because basically async and the pure part of rendering effects are always scheduled to happen before the actual rendering or the rest of the side effects work. We kind of bring back that model with laziness by basically giving these a special time to execute. Yeah, except the biggest difference between this is we take a function, so ours are dynamic. They can change at runtime. But yes. Yes, you guys are hitting on it. This is a big part. The thing is, end users almost never write render effects. This is what the JSX produces. You don't write these. You generally just write your data and do that. I'm talking about what this turns into. Right? It is a lot like the React split here, and I think that's something valuable to learn from React from that. Right? That this is how they keep their cleanness. This is how they basically can solve the concurrent rendering and stuff. This is better than our current solution, which holds work, because now we could actually continue to update render effects even after that first initial render. But if end users, well, that's the whole thing. I'm saying end users don't need render effects, but effects at all is hard. Animations, places where you read the DOM, this is generally where it is. You need that entry back into the system. There's events, like when the user clicks, and then there's, post-render type effects things like, oh, this updated, I need to read a value from the DOM or whatever. The problem with that is there's a couple of things here. You are now responsible for hoisting this if you want to actually do these things. Also, I have to take SSR in consideration, things like out of order streaming. One of the big, like, even if you go back to eBay back in the day and look at their old fragment streaming thing, they had a concept similar to suspense. Sure, it was just a direct read, like promise into a component, like an await component or control flow. But what these patterns do with suspense is they invert control. So what ends up happening is you create some async data, you derive it, you put it in your view. This render effect happens under the hood. You're not really doing anything with it. It's just your JSX. And then you set where your placeholder boundaries are, like from a layout standpoint with suspense. And then the right stuff shows at the right time, regardless of race conditions or regardless of how these things kind of come in. Trying to hoist this yourself and losing that inversion of control when someone adds something new async downstream or something becomes a source of complexity. Like, yes, you can always hoist it up, right? I'm making the same argument people make against route loaders, I suppose, but the difference here is that we're actively trying to push the dependencies downwards, right? We want to flatten the hierarchy as much as we want. We want to get the async reads as close to the DOM as possible to do the least amount of work. So if we're pushing stuff downwards like that, we don't want you to worry about how to hoist it all the way back up. Right? The difference between this and a VDOM is a VDOM produces the artifacts. This is like not unlike what we've always done in Solid in terms of reactivity and data, right? We're not creating a virtual representation here. Yeah, and what you've noticed here is essentially we still have createEffect, right? I was just reading this whole thing. Like, we still have createEffect, right, for end users, but like create computed is not really part of this model, right? Which is actually important to talk about in a moment, because we're actually we actually keep on parity, if not reduce the number of primitives here, and that createResource becomes createAsync essentially. createRenderEffect changes its form, but no one uses it directly anyways. createEffect still exists. This better sets up things like concurrent transitions. You can see the pure effectful split. This better sets up not needing null checks, meaning the awareness of async is a lot easier even when you're deriving async. You know, stuff just kind of, you just wire it up and it kind of fits to where the dependency, like where you need it in your UI. But another side effect, so to speak, of getting rid of lazy is around scheduling. We have something today installed called createComputed, which runs before rendering and does side effects, which is like the dumbest thing you could ever come up with. I did because these are use cases. It's like all the reason React tells you not to use effect. But if you, we covered it on stream, but in their docs they actually suggested, rather than use effect, just write to the state while it React's rendering, and it's probably better than using use effect. createComputed is our version of that. It's like the thing that we have as the escape hatch, in a sense, for all the things you should never do, because you should be deriving data as much as possible. But createComputed is really easy, where you can have a signal and then have it, you know, like sometimes deriving data is hard, right? Like, because you're like, what if I have a source, you know, coming in from above, and then I want to keep my internal state. So like as you edit it, you know, you have a signal, but then you want to make sure that whenever the props change, you overwrite that that signal with the value from the props. I'm trying to think of like the perfect example of that. Get rid of all of this, but let's pretend button was, you know, like this, right? And then, you know, it doesn't really matter, but you like, it doesn't, I don't have anything here, but like pretend you had like in here you had I don't know, value, set value, okay, equals create signal, right? And then you might initialize it to props.value, let's say. Okay, button's not a good example, but then you might go, okay, create computed, or you might say create effect. But the problem with create effect is it runs after rendering, so everything's a double render. But you do create computed and go set value props.value or something. And then this way, you could have some logic in here that, like, you know, whenever you do something, I don't know, I've just got a button here, you basically update the value of this, and then when the props change, it overrides it. This is very common kind of synchronization thing. And I talk about in my derivations of reactivity, how synchronization is not great, right? I actually have it right here. See, synchronization, state A, state B. Okay, that's derived. And then synchronization would be, where is it? Yeah, okay. Derived, upper name being uppercase version name. Synchronization would be having state of upper name and an effect that writes to it every time you run it. And the thing is, the difference between derived here and this effect is it's possible, and you see it here, it's possible for me to write to that signal myself independently of this, you know, reaction. The problem with this, though, is we can't track up the graph. As soon as you inject a signal in here, we lose all those properties that we like about derived data, because we don't know anymore, right? With a memo or derived data, you can always go, okay, you read this, you read this. Let's say this, I have it in my example here, upper name. Let's say our state is upper name now. We don't know that this effect updates upper name. See, whereas here, we know that upper name depends on name, right? Like, we can see it. It's like in here. We track it when it does it. But here, upper name has no idea that it depends on name. This effect just writes a value to it. It doesn't realize that it depends on name. You've broken the graph, essentially, by using synchronization. Here, it's a track dependency. Here, it's a tract of this effect, but this has no idea that it's been derived, which means that you lose all those nice properties of signals. Yeah, local copy, right. I think these are the places. I think that these are the places where we need to look at the primitives again. Because like we don't want to encourage this, right? One of the things that we've been talking about is something called createWritable, which is essentially, which example here? The idea is instead of writing this, you would write this. It's slightly different, but it changes this considerably because now you have a primitive that's aware of its dependencies and can still be overridden, but then you know, trace back, right? This subtle little difference is generally the pattern that you essentially should be following here. We should derive on top of this data and then mutate it ephemerally, because ultimately, eventually, the source of truth needs to get back and drive down from the top, right? You need to save it to the server and have it come, back down. But we do have ephemeral state, and we want to be able to like not rely on synchronization. So this is the kind of thinking or where we're at. The funny thing is this is actually not that hard to implement in Solid. It's actually a memo of a memo. It's like second order memo. I'm not going to pull out the implementation right now. Probably it's like in a Discord chat, and I'm probably going to piece through it a bit. But essentially, the idea is you can basically make like it's like you can, or no, it's a memo of a signal. Like essentially you derive a signal. So instead of like it returns a signal essentially, so that when this changes, you get a fresh reference to that signal. Right. Yeah. And there's things called writable computeds in Vue and Knockout, where you can set custom logic. But I'm saying is like we really need to get away from synchronization. Another one where this is tricky is stores. But like what I'm trying to get at is instead of props.value, this could also be some async thing, right? So like, this could be like const my user equals createAsync, fetch user, which is going to give me some promise or something, fetch user props.id. Okay, right? And then what I'm suggesting here is then you could be like, look, user.name, and now name set name. Like this is the sort of, you're kind of making a derived, like you see how we keep the graph this way. Obviously, solving this for stores or deep proxies is something that's a little bit more challenging. But essentially, this way we keep the properties, and you don't have like, the problem is if you start doing writes while you're deriving stuff, some nodes might run more than once. They might have the old value and then you write it and then they get the new value. You want to kind of avoid this kind of jitter, so to speak. Help with the optimistic UI? Yeah, I mean the other change helps too. I don't know if any of you guys have been trying to build the Trellix demo with Solid. You basically need to merge stores essentially to get it to work properly, and we don't have a primitive for that today. And it's hard because you have to build it into because of the way our resources work, because we don't have the derived async currently. it's actually a bit of a pain. You end up just using like an effect or computed to write to a store to do the diff with the async thing, and at that point of read is where the suspense triggers. It'd be way nicer if we could just derive it and then merge the data in the derived value. So yes, I think this has benefits in that case as well. Yeah, I mean, the trickiest part now is there's a certain duality between primitive version and the store version. Like there's createAsync. If you've seen the router, we also have createAsync store, which automatically diffs the data coming in. There's createWritable again, which works on a single field. You're probably going to want a version where you can basically diff the data coming back from createWritable. As I said, these cases, yeah, these cases will allow for keeping the directionality and allow for super fine grained updates. Essentially, like if anyone's used createAsync store in like with their data thing and without like trying to merge the optimistics, like when your optimistics kind of separate, like this thing is like magic. Like you essentially just like get the data and then it diffs the data and then automatically just updates the one place in the UI. No components rerun. It looks insane. Like it looks like you're like, how is it that I'm like using this with like cache and actions from the router data loading patterns, and it's revalidating and fetching everything, and then like literally nothing reruns, and it's just like bang, this little one tick in the UI updates when I'm getting fresh server data in validation patterns. Like it feels super powerful. We need the same kind of power in on the memo. And actually, if we did, we wouldn't need createAsync store. We could just use createAsync, and then whatever like create diff or whatever was, like whatever the primitive was, could just wrap it, and that would handle both cases, both diff derived normal data or diff derived async data. This is the important part you can see when you start dealing with these primitives, is the patterns just fall into each other at that point, because then like, okay, you have, whether it's a memo, whether it's async, whatever the source is, you have a common pattern for being able to handle, say, how do I do a diff of the data? And that could derive naturally from whatever source, right? As long as we keep the directionality. How do we, so this is, I don't want to get too, I'm very careful here of not getting too crazy down the rabbit hole of making a whole bunch of different primitives. The stuff that needs to be core needs to be core. The other things can be easily built in userland, async is important enough because of that different characteristic of lazy versus eager. So anyways. Well, are the links from YouTube not coming through? Is that the problem? Okay. Did you go? Yeah, the links don't come through YouTube. That they do come through Twitch. Oh, it's funny. I saw you talking about it, but I guess the links didn't get through. Yes, some people have made it in the community package. Yeah. Yeah, I want to see what that looks like. I want to know what the optimistic updates look like. Which brings us to an interesting point. It's an interesting question, right? It depends on how well we can merge the stuff, right? If we derive too much, are we keeping, like, I'm not, if we don't have to keep complete copies of everything in memory, then we're good. See, we do everything by reference anyways, so we don't really want full copies. We want to be able to, it's an interesting problem. I actually, there basically every one of those touch points would probably need its own copy of at least some portion of the data. So yeah, it's deep stores in this area is an unexplored area, and it's a place that I'm interested in. But okay. Yeah, I talk a bit more in this article I shared earlier where I talk about being able to control flushing. Again, but the async stuff, actually, I actually talk about render effects here. I use create memo here, but I realized afterwards the problem. Yeah, async components. I gave up on that because it's just blocking. It's confusing. Yeah, yeah. Never mind. I think I covered everything in this article pretty well. I think what I want to see is the whole effect scheduling suspense side of things. It's in the effect zone. It's in the ownership tree. It might be possible that can keep out of any kind of common piece of runtime. But it gets harder and harder when we start introducing ideas of async, where we could, propagate it through, right? See, I've got, if I go to Solid.js GitHub right now, there's a project here. And you guys may have seen it, may have not. It's kind of gets buried down here somewhere. It's called Solid.js/signals. And this is very rough. I only started looking at it again this week, as you can see. But this was the beginning of an implementation. And the truth of the matter is, I haven't actually played with it all that much. I was trying to get effects to work. And what's interesting here is that createAsync is implemented, a basic version of it that Milo implemented. I don't know if I'm going to be happy with how this works yet, but it's here. So he's been doing a lot of research here on this. We have createRenderEffect, createEffect, createRoot, run with owner, catch error. This is the full API surface right now. Catch error, run with owner, createRoot, createRenderEffect, createEffect, create memo, createAsync, create signal. Yeah, that's about it in this library. It's pretty small. I think that Raheem and Milo have been working on it way more than I have. I was actually kind of thinking that I'd actually try it and see if it was like behaving the way I wanted to, but I don't know how much time we have to do that right now. But for those who are wondering if this is already in progress, it is. I ran the previous version of this through the JS framework benchmark, really raw, where I just kind of like hacked it together, and it was 0.02 slower than current solid in my local tests without doing any kind of optimization. So it's a good baseline to get started here. Yeah, let's just pull this down locally. Let's see what we can do here. Solid start. No. Let's see if I actually have it. I might actually have it from before. Let's see if I have it in fork. X Reactivity. Is this it? Is the original version of it? Yeah. This is the same repo. Yeah. Cool. Okay. Let's open it. All right. Look around. Open development. Okay. All right. So other thing we could do though, there's a bunch of tests in here, but maybe all we need to do is just build the library as is right now, right? And then just copy the ESM output into like the playground, play with it. Maybe I should install first, shouldn't I? Should probably delete the old dist folder because my suspicion is this is way out of date. This is, to be fair, I didn't test the latest version. I got in the other day, noticed that effects were running synchronously and I want them to be delayed. And then I kind of like was like, okay, well, it's gonna, okay, so what's dist here? Oh, perfect. Prod, node, dev, types. Okay. So I can literally just take prod here and all, what is it? About 900 lines of code here. Okay. I wonder if code size will be interesting. There's some big comments in here, so let's just copy that. And then looks good to me. Some of these things are exported that probably don't need to be. Okay. And then we can just call this signals.ts. Work. Post it. Beautiful. Import. Create signal from signals. Moment of truth here. This work. Let's just do both. Create effect. Hello. Set. All right. Please work. I haven't even tested this. So the tests work fine locally, but I have no clue what this will do in this environment. Did we get any errors in the console? I wonder if like I'm hitting on something because it's there's create effect here, right? Like there's definitely create effect. Okay, let's just do the whole thing. I wonder if this is like let's just and oh, interesting. It's in the actual console, but it's not in this console. That's interesting. Okay, that's fine. We don't need this console anyways, right? Yeah, I don't know why. Am I like... Well, let's not worry about that. Let's not worry about this. Was the create root even necessary? No, it wasn't. Okay. To be fair, we're probably just not warning, and I still think we probably should. If I do this, world, yeah. So what's interesting here is the create effect is already using this because let's play here. Flush sync, right? Let's go flush sync. There we go. Hello world, hello John. So first thing you notice about this system is it's doing global batching. like Vue, like React, like spelled basically like everyone else, right? Second thing to look at here. Okay, so flush sync works. Let's make const double again, like we did earlier in the stream. Create memo. Let's go console.log, do the work, and then let's go return s times 2. Create memo. Now, oh, I guess let's do, it's not double, let's do 2 upper. And let's call this one upper. Yeah, we see uppercase world and uppercase John and do the work twice. Now, sorry, I'm trying to get like I want this to get smaller, but yeah, fine. And then let's see what else we're just trying stuff. Okay, what if we get rid of the create effect? Yeah, okay. And let's call upper ourselves. Yeah, so what you're seeing here is that without the effect, the memo doesn't run. That's another difference here. So this is lazy, right? Upper never runs in this here. Flush sync doesn't do anything because there's no effect. Setting John doesn't do anything. It's only when there's a sync, when there's an effect, that the memo runs. So yeah, okay, perfect. Okay, so this is the basics of it. We have a lazy reactive system that does microtask-based schedule queue scheduling and auto global batching. Okay, you know what I want to see? I want to play with createAsync. Play with createAsync. I want to see how this works. Because I am curious. Let's do new promise. It's so funny because I have to like move this in order to new promise. Let's get res. Let's just set a timer. Do something like set timeout res world, and let's not uppercase it, world for 1 second, and then this no longer has a setter, which means this whole thing is pointless. What's going on here? Let's refresh it. Okay. So first thing this shows me is by default, this does not have my crazy behavior because it's asking me to null check this, right? Right, it's just doing do the work, hello undefined, do the work, hello undefined. Okay. Now, my understanding is that it's just because of the default of how this is set up that this behavior that I want does exist, but it's not how they defaulted it. Let's take a quick look at the code again and see what they're doing. Create async, write value, write signal. Okay, what I'm looking for, is there something called, let me see here. Utils. What's in utils? Nothing. No, I at this point you're right. At this point the flush, but that's a good question because at this point the flush sync I think is not important. No, yeah, sorry. The flush sync was just when so I can show that we could set it twice. So the flush sync doesn't make a difference here now. Now we're back to kind of natural behavior. I want to look at the implementation of createAsync because I know that Milo did a whole bunch of work here. I think we need to look at the what is this being passed into? Because I'm not seeing it right now. There should be a read. So he's doing read. And sorry, I need the code for this is in something called core, I think. What core loading? Wait. Read returns read. Wait goes this loading throw not ready error. Okay. So okay, that's interesting. So the question is, I'm just gonna go back to the playground because I guess I could have just looked at the code in the playground, but I think if we go in here and we change, find it, create async. What if it's wait? No. Here? No. Okay. I'm gonna have to look at this more. It's interesting. I actually see the code in here that suggests that. Oh, actually. No. Okay. Never mind. I see the code in here that suggests that it can handle the throwing, but I haven't looked at this very much. No, I never looked at Qt. Actually, people brought up to me later on, but most of my influence came from Knockout, then MobX, and then SJS. Yeah, it's hard to get around the small window. Yeah, it's fine. We can continue to explore this in the future. I just want to set the basis. I think I'm good on this for now because I, it's interesting because I see the code that does it right. If we look for wait here, it basically during the async time it's supposed to throw not ready error, and then if I look for not ready error, I'm hoping then it tracks it and then sets it out. So like it looks like the code is set up to do this. I just am misunderstanding how to actually trigger it because the wait seems to be only available on the internal node. And then if I had Milo, he could probably tell me exactly what I'm doing wrong. But I hadn't been able to test this yet. So I thought, okay, maybe I'll just try it right now. Because there's two computations here. There's signal. So he's modeling it using a signal, and then the signal read. I wonder what the double read does. Yeah. But then basically I would have hoped that this wait here would have been the thing that threw. I wonder if you like the problem is you actually have to like wait all the way through. I don't know. That would be interesting to say the least. But no. Well, no, that's the idea. Sorry, if I didn't explain this already, we're starting from the signals package. This was the effort. I haven't reviewed it in the very much in the last year, but this is the new like we're starting Solid 2.0 from starting from building the base primitives and the signals and then building everything back up on top of it again. Yeah. So like the idea here, like yeah, it's like how many places can I put wait until this works? But the idea here is that yeah, that in any case, the idea here is that we will I mean, effects probably aren't being batched anyways. Wonder yeah. Yeah, no. I don't think I'll be able to get to there. The idea is this work will then become the foundation we build the next version of DOM expressions on, and then everything kind of channels out from there. So it starts with rebuilding the reactivity system, and then on these primitives, which we've identified, and then it will continue to kind of go out into the rendering, and then on it. This is the big part. When we get like the current version of these signals don't have concurrency or transitions. The async model isn't quite where we want to get it to yet. But essentially, when we build out this reactive system and add those couple of features, most of the rest of the 2.0 stuff will be built on top of it. This basic, I think the brunt of the work is in this signals repository, and then from there, we'll have to do a bunch around DOM expressions around, the split between server and client. Like server has some different behavior. Like right now, we don't actually have reactivity on the server. That can aliasing and then kind of build out there to Solid 2.0. But like the big chunk of the work is this stuff. Just haven't, as I say, got back to it. Months. That's my that's what I've anticipated. This I'm hoping to get the right async model and get transitions in the next couple months, couple weeks, and then building out the rest of Solid at that point. That part should be yeah. My target was for the fall. But yeah, just to give you kind of an idea. No, exactly. Like, yeah. So, this is where it's at today. The basics of the system are good. I know they're performant. We need to work on the async model and the flushing model, render effects. I knew I was a little premature coming in here today. I was hoping I could just like play with it and see it. We see the async stuff works. It's just not doing the behavior that I want, quite the behavior I want to get to yet. But this is the base place, and I'm going to start putting a lot more focus here. I've been very distracted with Solid Start, so I'm very excited. That's the big thing. I'm very excited here. We've talked about all the decisions making that got us to this point. Talk about all the different kind of things, and while I've made a big thing out of it, the end result actually shouldn't be that big, so to speak, right? It's you make a lot of hard design decisions, and then like we're talking about, I can see the library getting a lot larger when we add some of these features, but like tree shakeable. The signals library on its own is really nice abstraction. We didn't talk about it here, but like create store is in here, and we simplified create store's implementation as well. I can probably show it in the tests. the store implementation is also in that all that code, that 800 lines or whatever. It's about 200 with all the comments and TypeScript and everything in here. And the biggest difference that we've been looking at with stores is let's look at an example here, is using produce as the default API for it, so that you would use localized mutations, no more of this weird, undefined merge object, not merge object stuff. It's a lot like Immer this way. We still offer the path syntax, but the store basically, set store call gives you reference to something that you mutate. I think it would help people understand what's happening a lot better. We're still keeping the read-write segregation because that's still important to us, but especially because when you pass stuff through, you don't want anyone just to write stuff randomly. But the idea here is that, it allowed us to simplify things and actually make it represent something that's more like natural JavaScript than like our DSL that we built on top. Yeah. Anyway, I think we're good on this topic. We should start talking about this week in JavaScript because there's some good stuff here as well. Give me a second when for me to kind of switch modes here, but we haven't even talked about solid start yet. So yeah. What does Flush do? Flush schedules when the effects run. Yeah. Like it's basically saying like run them now. Essentially. All right, let's get this going. Thanks for joining me today. I know it was a little rough towards the end. The learning part was good. The future stuff was a little bit rougher than I'd like, but I think the direction is actually getting pretty clear, and the trade-offs a lot better understood. Yes, yeah, it's kind of ironic because I did so much work to give like a mutable JS interface over something that is actually mutable underneath the hood, and Immer gives a mutable interface on top of something that's actually immutable under the hood. We first played with this store design when I was working with Tanner, so because he refused to use Immer for some reason. I guess he didn't want the extra bloat, but I was like, this can be where your interface is. If you want the router to support both sides, have it use Immer for React and have it use our store API for Solid, and just swap it. And then all the rest of the APIs can look the same. React can get its immutable stuff and do its updates that way, and Solid can get its fine-grained updates. Because like the thing you have to understand is Immer lets you write mutations, but you still have to, under the hood, it still has to do all the object cloning and all the like reference, like structured cloning and like all the checks in React as it renders and all that kind of stuff. In Solid's case, like just, the mutation literally, like it's a proxy. It's just like trigger this one spot, and then it'll just trigger the signal over there. So like the overhead is significantly less, on our side, but I mean, yeah. Yeah. It's so funny. I've really liked strict contracts and stuff of immutability, and I've always tried to kind of push people that way because I find in the long run it makes them do the right stuff, which I think is ultimately very important. But I can understand why people might not have the same opinions as me on this stuff. Yeah. Anyway, okay, yeah, I think I have everything set up for this week in JavaScript. So we should get started, shouldn't we? Roll it back. When did this week start anyways? What are we on? With 22nd? There. Was there actually that much stuff this week? Just scrolling. Yeah, there's a few things. Okay, let's keep going. Yeah, local mutability is fine, and that's what we're playing here at. All right, let's do this. Okay. Let's switch over. All right. And let me get my banner and talk about this week in JavaScript. Not nearly as much as trying to catch up from 3 weeks last time, but definitely a few things definitely came up. So I'm happy to talk about those. Let's get started. There was an interesting TypeScript discussion that came up last week. I guess last Friday, and there's a whole article here about like what happened to it. Yeah, you can't make children type safe in React and TypeScript. And it's talking about this whole select option thing. Component is always a JSX element, right? So I like this. The reasoning behind this is always true, and this is one of the earliest issues we actually opened as part of the solid community on TypeScript, because like we're trying to be like, why can't element 2 be a div? Well, you know, we tell everyone a div is a div. Why can't element 2 be a div? And like they're talking about all these things. Option as any, I should be shown below. Funny enough, this does work if I call option manually, yes, but as you call as JSX, it does not, right? It's not possible to restrict it. Okay, blah, blah, blah. Okay, we know this. But I thought there was something here about, let me see. And would you ever even want to? Okay, so Dan's actually agreeing that you'd want to there. And I was actually saying that it was kind of annoying because the div equals div thing. So actually it seems like he's in agreement. Why you would want it? Indeed, restricting direct children type is pretty useless because okay, because you can't pass my option even if it renders option. This is one point where flow type is innovating over TypeScript to check render types. Well, see, this is the thing I'm not as clear about it. Maybe you TypeScript people can help me out here. I don't care if someone passes, and maybe people do. I don't care if someone passes capital option or my option. I care that they ultimately return lowercase option, right? And if the types work the way that our types would, we could ensure that, right? It's hard because our functions are just functions. We wouldn't want to ensure that people only return one type of component, I suppose. But it would be interesting if we could ensure like the right DOM children get inserted. Like, I mean, this starts getting like really crazy, but picture if you could actually know that like you can't put a certain type of element inside another certain type of element, and TypeScript could tell you that. Right? Yeah. If you don't need render types, if we got return types, it would be enough. Exactly. Yeah. A few folks are like, yeah, we love typesafe slots. Yeah, it's interesting. But yeah, so I kicked up a little bit of a thing on this. This is like one of those things I would love to see TypeScript help people, you know, get from, you know, not just React. There's a few things on this list. This is one of them. It was a good discussion. It's interesting to hear that even the React team, there's a few cases where they're like thought about it. But I don't know. This is like first week that I used JSX with TypeScript. Like we basically identified 5 issues. I think 1 or 2 of them have been addressed now. This is one of the 3 remaining ones that I'd just love to see. To be fair, if it's not immediate children, it doesn't actually do a ton. But I mean, it's still really interesting to think that you could actually be like, no, you can't put, you know, I mean, I guess most rules in the DOM can be broken anyways, but it'd be interesting to say like, you can't put this type of element inside of this type of element, right? Like this is an actual problem we have with SSR, because they'll like get pushed out. Like picture if you could say like, you know, tables, they're very specific on which elements go inside which children. Like picture if you can be like, no, you can't put that element there, and TypeScript could tell you. To be fair, a lot of things would probably just be anying anyways. I don't know. It'd be interesting. We talked about this a bunch last stream. I just retweeted the Python paradox. It's a good read for anyone. All right, so we got the React compiler thing. Yeah, and we have the Wiz thing. Okay. Let me just check if there's anything else I want to talk about. Yeah, okay, this is low-hanging fruit. There was this poll this week where people are asking web devs what the default HTTP method for the form element is. I'm gonna, hey, I've got chat here. Do you guys know what the default HTTP method is for the form element? Yes? Yes, it's definitely put and delete. Yeah, thanks, guys. No, seriously, can I? Right. I mean, no one's gonna admit that what they voted for now, right? Yeah. Yeah. Okay. Thanks, chat, for participating in this. I see a lot of gets, which is the correct answer. I do see a few posts or people say I voted post. Because, like, honestly, post would probably make a ton of sense. I'm not sure I even remembered this when I first was working on this stuff. I think I did because I was working in Marco and it refreshed me on it. But, like, if you actually go and do a form action in Solid Start, we don't do what Next does, which is automatically make it a post. We tell you to add the post method to it if you want to use an action. We're like, we only support post actions on, so please put the method equals post on it. So that's our middle ground, right? The remix guys like Brian Florence are kind of like, they made it stink how Next. A little bit, not much. That Next high, and RSCs can like say like post by default, and more than that, they hide that fact because you don't write method equals post. They just like automatically make it a post, and then the web the default is get. So it is kind of interesting. Right. So yeah, a lot of people from the single page app world never needed to know this. And that is what Adam Rakis is saying here. I know he's a bit of a shit poster, but he's like, if knowing shit like this mattered, more devs would know it. Learning TypeScript is more value career, learning React is more value, learning Next is more valuable, learning Solid is. Some people thought this was like a slight against Solid. I think he just literally ran out of characters. Because he's been very supportive of Solid Start, especially since I chewed him out on Signals last week. So yeah. It's funny. I bet if you pull the button, they can get it right, but they wouldn't vote a to-do app. Yeah, no. This is the problem when you diverge from standards. I think it's okay to say like, look, they should be post, but then have a capital form component. When you Next has a lowercase form, which makes you kind of be like, oh, I thought forms just worked like this, and it's like, no, they don't, right? Like our middle ground isn't great because now it'll complain at you, but at least you know we're teaching while we're complaining. So yeah, it's interesting. I thought this one was worth pointing out because this conversation just keeps on going on. Where's this one? 676. Adam goes on to show a very like broken JS example and is like, look, if you don't know this, then you don't know JS. Like basically just being cheeky, but I don't know. There's a lot of weird stuff in the DOM. You probably should know your tool, but it also probably like if this was something you knew, you literally, for the last 12 years, could have coded and never come across this and been perfectly successful in web dev. Like, this could have not mattered even remotely. Anyway, let's keep on going. What other cool stuff here on the random bag? Oh yeah, this is a fun one. This might ruffle some feathers, but if you're using Next.js and SSR mode for documentation, you're probably making a mistake. I like this graph. Sometimes we raid Chris after the stream, but he points this like little pocket for SSR. I don't know if I agree. I think the SSR pocket can extend in space, but to this point, I'm in agreement. You don't really need server rendering for docs. Probably not. The question is how small this portion actually is. What we're seeing is this portion is actually trying to eat this portion. Right? But yeah, I don't know if this is that all that controversial. Did anyone else reply? Oh, there's Theo. Going further left with SR tech is a mistake. Funny enough, I see this with remix devs and Next one, since Next aggressively builds routes ahead of time. Going further right with SR tech is becoming more and more worthwhile just for data loading paths. Yeah, I mean, this is an interesting one. Next caches so heavily that people end up not doing that much dynamic stuff with it. But this is the hot spot, right? You see like eBay, right? This is where, like, we all know we can make these performantly. It's trivial. This is where performance starts to matter, and it's like right on the flux point where you don't want this. So this is almost where like the whole conversation is focusing on. But I think in general, like Fred from Astro had a graph kind of like this, and he tried to place the frameworks on it. I think this is a pretty good look at kind of where these things kind of sit. Okay, we have okay, let's get there in a minute. Let's some quick solid.js news while we're going. Attila's been on fire, or Attila, however you say the name. I asked, and everyone's like, "Oh, it's all good," and I'm like, "Well, that's not helpful." But yeah, great podcast talking about Solid for an hour as an outsider, not just me chatting off. I thought this was actually really, really useful one from a third party, like from a React developer standpoint. I think it helps. You know, I've been so deep in Signals, I don't always, I maybe can't relate as much anymore. So I quite enjoyed this podcast. New guide on how to use create extensions using Solid.js. Pretty sweet as well. I saw this and I thought this was kind of interesting. Nuxt Hub, because we both use Nitro under the hood, they had no problem just like deploying a solid app. Just worked straight out of the box. This makes me happy with Solid Start. It's nice to see this kind of like benefit of everyone just kind of using the same tool and just being able to just get it to work. Okay. Yeah, okay. We'll do that one after. Let's keep on going. No, let's go to the next one. Okay, let's talk about this one. I'm going to change my view here. Just give me 1 second. I'm going to change what I'm presenting. Okay. Because I'm going to present a Chrome tab. Oh, will that work? Yeah, let's try this. Do you see the weird borders I see? It's like cutting it off on the top and the bottom. Anyway. Okay, well, I'm glad this looks okay for you. It looks weird for me. I thought this was cool. new article. We'll have to open it in this tab for this to work. Oh, it's opening it in another tab, of course. Damn it, I didn't think this out very far. Okay, give me a second. We will do what I want to do in a second. For now, I'm just going to share the whole screen. We'll come back to what I wanted to do. He talks about how the React compiler uses type inference to figure out how to auto-memorize props, or auto-memorize stuff. So he's showing like, here's like a simple example where you memorize the component in React as a user first name, like that. He's talking about identity. So basically, because they know that a primitive can be the same, but an object can't be, if they know that something that calculates tax can only return a primitive, it can inform their approach here, because he's saying naively you could just use memo to wrap each of these calculations, but because they know the type is what the type is, they can decide to not use it. So he's explaining how they do it. Solving the equation. The process of solving these type equations is called unification. The unification process attempts to find a substitution of type variables that make all the type equations equal. Solving the type equation for our example are pretty straightforward, blah, blah, blah. The point subtotal, we don't know its type, blah, 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 blah. Now we're getting back to our original question of price component. The compiler can infer that all the values are primitives. There's no actual need to memorize total, subtotal, or tax in this price component, saving bundle size and memory. So instead, they basically don't memorize this and then just check the primitive value and do a shallow check, kind of similar to how Svelte used to do, which is they create their element total. So basically, if it's not equal, replace it. Otherwise, return the previous value of T1. That's essentially how their compiler works. Right. So they were able to use rules of React and say, like, you're mutating local state without using set state. Interesting stuff. The funny thing about this thing is, I think this is very powerful because they could tell that the work here isn't expensive because it's just an equality check because of the value. But so that answers like a pretty important question. But what I thought was interesting was Devin Gavitt's response. In your example, what if calculate subtotal or calculate tax was a very expensive operation? Wouldn't it be worth memoing then, even if the inputs were primitives? Great question. There is a potential trade-off. We've been thinking about the compiler as a way to bound re-renders. In practice, this hasn't been a problem, and not memorizing everything has been the right trade-off considering memory bundle size. Interesting. So in that case, you'd still need to use memo manually, I guess. Perhaps worth reframing the compiler as something that reduces unnecessary re-renders rather than something that optimizes performance when re-rendering is necessary. I've seen it marketed as you'll never need to use memo again, but it seems like it's probably not really true. It does absolutely optimize performance when re-render is necessary too, because of a memorized component re-render is much faster because not everything has to be recomputed. Right, okay. In my opinion, it's still a React issue when compared with something like Solid. In your example, if only state changes, you would still call calculate subtotal even though the items didn't change. It's less granular, so you still need to think about what to manually memo. Oh, he even mentioned us. I missed that. Yeah. Okay. So yeah, this was an interesting conversation. And the reason I was talking about it is I found this example really interesting because I think they did it intentionally, perhaps, because I used this exact example in one of my talks. Right. Let me show here. Share screen. Now I can do this because this is the easiest way for me to get it in here. So let's do this.
We can do it for further navigation.
Oh,
we could base
no one. So it didn't remember my timestamp. I hope other people got it.
React team that talk about auto reactivity. it isn't only that memoization is insufficient to solve the performance consideration, it's that with implicit memoization, it's a lot harder to explain the mental model.
The audio is coming through, right? Did I share that right? You guys gonna have to tell me. Okay.
Right? What do I mean by that? Well, pretend you have a bunch of code that just looks like plain JavaScript that runs from top to bottom. How can you, like, does it still feel like it runs top down if only certain parts of the code just happen to run? Like, this is a fictional situation. No one knows how the React compiler is going to run at this point, but I just wanted to kind of do this mental exercise, because when I was working on Marco, we had a very similar kind of concern, because pretend you put a console log in each of these functions. And this is just like a simple setup where you calculating, maybe you went to a restaurant, bought a bunch of food, calculating the total, and then you're calculating like a federal tax and then like a local tax. And obviously, the first time this runs, it'll run it and you'll get 3 console logs, right? You'll get the one for the subtotal, you get one for the tax, and get the one for another tax. But the question comes in, what happens with this code when you go, oh, I'm in the wrong state or whatnot, and you just switch that and you only change the state tax rate? Well, if it was most frameworks today, it would just rerun everything, you get the 3 console logs, and you see the output. But would it be strange if just the last function just happened to run? Now, I've inlined it so it's very clear to see that only that function depends on the state tax rate. But it could also, this could have all been inlined, like just a bunch of logic inside your component, and the compiler just decided, oh, these lines of code need to run, these other lines don't need to run. And it's kind of hard to actually explain. I think it becomes difficult to explain it top down. In fact, you might start talking about data dependencies changing. And honestly, if you've used React anytime recently, like hooks or whatever, like you're familiar with talking about data dependencies. And this is where I'm getting at. You might even describe this as being reactive. It's not about memoization anymore.
Anyway, yeah, I just wanted to show that little clip for a second, because it was just interesting that that piece from that talk basically ended up, and I gave that talk a few places, but that it basically ended up in that article almost as the actual example. So yeah, I'm gonna swap this back so I can share everything again. But yeah, it's interesting, because I think that the takeaway for me here is, like, it's what Devin said. It's like, don't get me wrong, like, sometimes in Solid you have to decide what's expensive and when to create memo as well, like when you want to do a calculation. But it's like, I think React's doing the right choice of not over memoizing, generally speaking. But it's important to realize that they're not like removing the need to be aware of how data flows through their app. Like it's a better default, right? I think that's how I wrote it. This optimization will allow some code that's written kind of naively to operate better, but it won't necessarily optimize. Like, it won't necessarily, like, there's only so much you can do, right? It's not going to necessarily make your, like, yeah, I don't know how to phrase it, because it sounds like it'll make the worst cases, not even the worst cases, better. It's kind of like the default is in a better place, which means it'll have an impact across a lot of projects in ways that will be meaningful, but it's not going to probably make headlines. And when you need to optimize, you're still going to need to go in and optimize. Yeah, what Devin said. Yeah, I mean, it's a really cool thing. It's just, it's interesting. I feel like it's because like React's at a point now where like they don't have all enthusiasts running it anymore. You have just average people, and a change like this will make the average developers improve the average developer's life, right? Like this is one of those places where you're putting like I think we have a response here somewhere. Can I say something? Writing your own compiler in a whole type system with interference, at least now, worst pair of TS, not just do memorization for web framework sounds like jumping the shark. And then Lauren Tan, works on the React team at Facebook, said, doing it this way is hard mode, but it speaks to React's principles of absorbing complexity so product code is easy to understand and change in isolation. The compiler is an extension of that vision. Use standard JS values, idioms without compromising too much on other things. Right. So like, this is one of those things where I feel like when you're already at the 80-20 split and you're like, okay, we know that the last 20% is really hard to get, but we feel like we've exhausted everything else. We're just gonna like pay the 80% cost to get the last 20%, right? Like that's where we are in the cycle here. It's like it's time to approach the hard problems, things that have less return, like absolutely, but have the ability to like smooth out the edges, Requiring a build is already too complex. It's funny, Joe, you make me, I was looking at my articles, and I know this is a little bit of a tangent, but I have plenty of these unpublished articles that I just think maybe I should just, they're like opinion pieces. I should just publish one of these days, because they're like, what you said there just got me thinking about it. Two-way binding is a two-way street. Whole article about that. Never released it. I wrote this one, when did I write this one? About a year ago. Looks like I wrote it like March 2023. Custom JavaScript AST transforms are irrelevant as ever. This is talking about no build is a myth and how it just can't compete. That was looks like July 2022. Evolution over revolution. Talks about design principles, anticipating rewrites, value of simplicity, right? Simple over easy. I don't know. I just never released these front end platitudes. Talking about when we get hooked on like short statements that sell it, but that are actually not even true. Like they're actually not even close to being accurate, but like that's what everyone repeats long after the technology's there. Like virtual DOM is faster than the real DOM. Yeah, maybe I should publish something. The fallacy of universal solutions. Yeah, I don't know. Maybe thinking Marco. Oh, 2021. I don't know. I've got like 5 articles that were just kind of like sitting here. Really look forward to debugging this compiler code. Publish it all. Yeah, it's fine. This is. Have you ever? What was that? What's that book called? If you ever seen the cover, you know what it is. What Crossing the Chasm. Fred, I think, sent me this book at one point. He thought that it would help me understand how to find success. But if you look at the actual cover of the book, it shows the classic adoption curve. Maybe I can find the image. I can blow up the cover. No, it's just going to be small everywhere. But can we blow up this image? know, I love all of you guys, but the truth is, you guys tend to live in this front zone here. Everyone who watches a stream is probably over here, where they sit on the adopter curve. Sure, at work they might do something, but their personal interests, they're innovators, they're early adopters, right? That's why we have so many people who build their own frameworks or involved in open source here, talking here, right? We were just talking about Joe, who creates Loom, which is a web component library built in Solid that does 3D, does 3D rendering with web components. Crazy library. So we've already mentioned a few other people already in the stream. So the funny thing is, Solid has been trying to figure out how to jump this gap for a while here. See, whole product solution. This is why Solid Start has been so important, because it's how you show that you can cross this gap, right? People, the bar for this keeps on getting higher and higher, right? The shift change. The thing is, React, so a lot of us frameworks, even Svelte is just kind of getting its latches on here. React's kind of here, but they're struggling with I still use Java, so they're trying to figure out how to get here. I mean, it's crazy when you consider how popular React is, but when you look at the whole entirety of web dev, how many sites are React versus jQuery or whatever, they're definitely they're in a point where they actually have a lot of this market. In fact, they're losing this side now to a certain degree, and they want to cement this area and even get some of these guys. And this is the scenario we're in here, where if you look at the under the curve size, this is not even properly represented. This area is so much bigger than this area, right? Right, so always with the hard truths. Some are innovators, some are unemployed. Yeah. Yeah, I was just getting there. Sorry, maybe there's a delay. It's because the total area underneath this greatly exceeds the other side. Like the volume here is exponentially bigger than these. Yeah. Couple orders of magnitude bigger, yeah. Green is PHP. Yeah, I mean, yeah. I guess it's all their own chasms, their own challenges, but yeah. But yeah, essentially, I'm just kind of pointing out here, this kind of thinking diagram is why React is shifting, I think, over time, because they have much bigger fish to fry than us. We can sit there at the front of the curve and be like, look, our stuff is so much smaller and faster and better, and we might even be right, but who cares? So, it's awesome to see this whole arc with React in a lot of ways. The fact that me, someone who goes on the record to say I love React, it's getting to a point where I'm going, oh, I'm not sure about this anymore. It makes me uncomfortable. Means React is in a good place. It's fine. They'll leave all the people with like-minded to where I'm at, to come and use Solid or whatever. But yeah. Yeah, React is still growing at an alarming rate. It's not slowing down. There's so much volume in that area. Right? So anyway, it just interesting observations about growth and where things head. Anyway, let's keep on going. Here we go. Are we ready to talk about Angular and Wiz? We're going to talk way more about Angular and Wiz next week because we're going to have Jatin from the Wiz team, friend of mine, come and share all his wisdom about Wiz. He's been working on it for several years now, and he knows his stuff. A lot of people hadn't heard of Wiz before this week. A lot of you have, because Misco has been citing Wiz for ages now, talking about Quick, because it was the framework that inspired Quick. But you know, all his wisdom sounds like a Wiz kid. Yeah, well, the funny thing is, if you actually see Jaden's username on Twitter, I think it's Wiznastics. Yeah, people want to know what's up, so let's talk about it, because I am a little bit closer than this. I saw this actually, it even came up like on an internal feed at work where people were like, oh, this Angular Wiz thing, does this mean anything for us? And yeah, let me talk a little bit about this, because not that I'm officially affiliated with the project, but I know the people in the teams. I've been talking to them about this for months. I may have accidentally leaked that this was happening on stream last week. You guys may have seen that. I didn't know that it was a leak, but if you remember that long conversation we had with Adam Rackett, where I was just like, signals are the future, signals will take over the world, blah blah blah, you just don't get it, you know, being all melodramatic, perhaps. Where is it? Yeah, if we get down to the very last part of the thread, 3 solves everything. 4, I think I cut off early when I was reading it out loud, but I got here, I'm like, look, maybe you don't need it, maybe it isn't necessary, so get a second opinion. Ask Rich or Evan why they're taking their frameworks felt and view this way, or Misco, how does what make Quick possible. Jason, why Preact decided to step out of React Shadow, why Angular is going to migrate their whole community, or how they see a future to merge with Wiz, which powers Google search, photos, and Gmail. It just goes on. I don't typically like shouting it out, but I figured after 8 years, people would get it. Maybe they do. Yeah, so I didn't realize, I didn't really think, I guess. I might have accidentally let this one slip last week. I didn't know if it was exactly a secret. If you actually look at that, Jaden replies, and he's like, yeah, signals is what makes this possible. So I was like, okay, maybe it's okay. Yeah, thanks for coming by today. And yeah, I mean, the gist of it, and I think I showed this on stream before, is like, there's basically a path to resumability. Misco is right that current frameworks can't very easily be resumable, but if you fully get into signals, then there's a path to get to resumability. It's like a hop step. You like first kind of got to get into that to get to the next stage. You need fine-grained reactive rendering, and then you get into resumability. Wiz did this though without resumability, without signals. They had their own kind of approach, and Jaden's going to talk to us about this historically. And it was kind of difficult to use. I don't want people to get strong. Wiz was the first, like, it is the resumable framework. It is the blueprint for this stuff. But the DX was nowhere near what we'd expect for a JavaScript framework. And it's been incredible work here when they realized essentially that signals were the bridging gap to get the DX that they finally wanted with Wiz after all of these years. Essentially, it basically gave them that mechanism. And Angular was working on signals because, you know, as you know, they had the interest in it. And this started this kind of thing. I met last fall with Jatin, Alex, Pavel, the whole, you know, Angular Signals team and Wiz team, and we discussed, you know, what problems we were facing, what we were thinking about in terms of the future. We talked a bit about async flows, about concurrency, a lot of these kind of ideas. It was right after I wrote that HackMD, actually. because I was like, we were very much on the same page on a lot of these kind of problems. So it's not surprising. And with the Angular team, and Wiz team and whoever else is working on frameworks at Google, you easily have several dozen people that can work towards making this thing a reality. So yeah, it's going to probably take a bit for it to completely merge. And what we're seeing is, on the first side, Wiz adopting signals, which is actually what they're talking about here. Because YouTube, they've been trying to get better performance on YouTube, so they've been trying to bring Wiz in. YouTube was originally written in Polymer, web component framework from Google, and they were bringing Wiz in to improve the performance. But like the DX thing was a challenge. I know that some Wiz had adopted JSX, and they're doing almost like React type rendering for a bit. Not quite, like it was still resumable, but it was like with like more, like they were trying to make compromises so that developers would want to work with it, and it was getting mixed results. And my understanding, as I said, Jen will clear it up next week, is that is that Signals basically help them find that golden path, so to speak. I love watching this talk, not because, it's just right here. Takeaways: performance by default, simplicity, maintainability. They're talking about signals here, and the fact that is like just the expected headline is so awesome to see. Like half of this talk is talking about how great signals are, which is really, really awesome. Like they fully embraced this. You guys are talking about what time it is? 4 a.m. Wow. Yeah, I mean, it is on the 80-20 thing, but it's not as far off. Like, it's a performance optimization that I feel can be done without impacting. Hopefully, if it can be done without impacting the code you write. I think that's the important thing here. I am worried about transparency, but I think it is something that's on my list. I think there's a lot of ways you can take reactivity. If you have an async reactive system that understands, like, that's pausable, like I was showing with the throwing and createAsync, then there's a lot of capability that you have in being able to like control that. The other part is the serialization. This is why Quick version 2, they're working so much on serialization. They have to prove that initial serialization cost during server rendering is worth it, because that's where a lot of expense is. Like, you are trading execution for bandwidth here. And if you talk to anyone, bandwidth is probably the most expensive thing for the page load, ultimately. Serialization problem is the problem we need to solve. So I'm going to focus on anything that reduces serialization over execution, probably. That's why I was interested in server components. I think there's a potential with server components to actually solve serialization. I think that is way more important than necessarily the raw performance aspect. We need to make sure that we don't need to that we can keep data on the client and data on the server. Yeah, simple versus easy. I talked about that a ton last week, to be fair. I mean, I didn't talk about it. There's islands in Solid Start. They're just hidden behind an experimental flag. You can just go in and turn it on. The Solid Start docs are in islands, but that's a whole other thing. But okay, I think there's a lot, like, just to hear the Angular team talk about signals was just like, it was a lot, because it's like this is like the reality we live in now, which is incredible, more than even like this news, which is also incredible. I think that it makes a lot of sense to Angular because they're enterprise, the type of stuff they're doing. Zoomability requires, like, it has importance to enterprise, but like there's a lot of pieces. It's the people in the middle of the graph that probably don't care about resumability as much. Yeah, so I'm I think that there's like Angular is continuing to show that they're like serious about the future, and I think this is really compelling, honestly. So it's so funny. People are like, "Oh, is this the end of Angular?" No, my gut is Angular more absorbs Wiz. We'll see how it goes, but but just because, but on the other hand, Angular also changes a lot. Like, but Angular's already changing so dramatically. Solid and React, as I explained last week's stream, are not going to merge. They're not in the same zone at all. The most similar framework to Solid is Quick, to be fair. I think. Actually, which reminds me, quick. I saw Shine in the chat. I didn't see you guys announce it. I was going through my metrics like I do on a weekly basis, and I saw that Quick hit 20,000 stars on GitHub earlier this week. And yeah, I mean, this, when you consider that no one knew what presumability was a couple years ago, I mean, to be fair, when I was working on Marco, we kind of come up with a similar thing, but we didn't have a name to call it. And when Misco was like, "This is resumability," we're like, "Ah, this is the thing." Now that it's as much of a vernacular, that people are excited about stuff like Angular Wiz. I kid you not. A few years ago, if someone said like Angular plus Wiz were merging, I don't think anyone would have cared. Like, what does that mean? What's presumability? But the work that Quick did, but getting out in front of it and showing what was possible, is like why we're even talking about this right now, right? Like, Wiz could have stayed internally inside of Google. A lot of things are like that. I think, as I said, it's a combination of many things, but putting zoomability on the map definitely is what Quick did. So I think a big shout out deserving there. Okay, fine. The most similar to Solid is Svelte 5. It is almost identical. Okay, fine. You win, Greg. Yeah. Svelte 5 and Vue Vapor are actually, yeah, yeah, okay, fine. They're like basically identical. Yeah. Those aren't out yet. But yeah, very soon. Yeah, it was Mitsuko's vision for Angular, and it's so funny if you watch the talk where he introduced resumability in 2019 at ngconf. People were basically almost apologizing for him. Like they were like the other guys were like, "Oh yeah, don't worry, Angular's not going to change that crazily. This is Misko and his crazy ideas. Sounds really cool. Wouldn't that be cool in the future too? What do you guys think?" Yeah, like at least that's the vibe I got from it. He came completely out of left field. You gotta understand, this was a framework that didn't even do hydration at the time. Like they server rendered and then they deleted it all and client rendered it. Like, and he's like talking about like resumability. Yeah. But yeah, I mean, I haven't even looked at this. I posted this like right before I started streaming, and it looks like people have caught on. So yeah, this is awesome to see. Yeah. No, Angular has way too much recognition everywhere. I doubt. Yeah. What I'm imagining is they'll have the ability to optimize Angular under certain cases that, like, essentially, yeah, it'd be interesting to see. I want to know. I can't say definitively. I want to know what Jadon thinks. Maybe this is talking about the future, and that's like, not to be discussed yet. But you guys can come next week and bug him about it and see what he says. Well, the thing is, Astro doesn't care what you use there, so I doubt they will add signals. They'll just be like, use whatever library you want. It doesn't. What's lovely about Astro is it's like basically like PHP or Rails, where they don't care what you do in the browser at all. So, yeah, I doubt they'll ever add their own signals implementation, or like there's no reason to cut off the others, so to speak. Right? Like, so like, if you, yeah, you can basically choose any signals library and have them talk to each other. Um, where do I want to go next? Okay, yeah, let's talk. Okay, there's one more thing, but maybe I should leave it till next week. I saw this post from Dimitri, and he posts very hard hitting, but generally speaking, very like thought, like very critical, but like also very, true statements, and he he basically wanted to call Google out on the patting themselves on the back thread, essentially. Sarah announced Angular is merging with Wiz. Let's just read this thread for a moment. In the thread, she makes a claim that Wiz powers search, workplace, it does, and YouTube, and that the merge will bring impressive improvements to Angular's performance due to Wiz. Yep. Right. Make no mistake, the amazing performance of YouTube looks like this. 3 seconds to render an empty page, 11 megabytes of JavaScript, blah, 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 blah. Keep that in mind, you read about this. So we have YouTube's own engineering leader, literally responsible for the abysmal performance described above. Congrats, great milestone. See, we're gonna have Jadon on here next week, but I hope that's why I'm covering this week, because I don't. Then we at Chrome's engineering adios monitoring graduate years of work at YouTube, miserable place. I think this is the right call for both parents. That's the future as well for success. Graduate YouTubers EM from technically great. Both frameworks bring strong complementary value propositions to the table instead of trying to see who can copy the other one better. If we leverage each other unique. Congrats to Google Dev Expert, blah, blah, blah. Oh, Shy. Okay, interesting. Yeah, I didn't even realize you're in this thread, Shy. Angular better GDEs, web performance thing, blah, blah, blah. But continue to pat each other in the back while destroying any semblance. Okay. So his point was that YouTube has terrible performance. The interesting thing is, I think YouTube had terrible performance before, anyways. We know that Wiz powers Google Search and Google Photos, and those are performant apps, or at least I know Search is 100%. I think what we're I think I think it's interesting because if you go on YouTube, someone was doing this after the announcement and looking, they're like, isn't this all web components? It still is. I don't know which portion Wiz has improved. I'm gathering they basically got in there and allowed for a certain amount of like loading time improvements. But yeah, I guess the interesting challenge here is question is they have shown the improvements, but it makes you wonder how bad things were before. That's at least my interest here. I think Jadon ends up responding somewhere in this thread. I saw it here, but it was an interesting look here because he's basically saying there's nothing to celebrate. I don't know. I do wonder. about the challenges of trying to build the stuff out at scale, because I heard it from the other side when I was talking about like the challenge of like getting the YouTube devs to want to use Wiz, like in terms of the experience, because like it didn't have great DX originally. And it's like, how much are the platform engineers, like the people who are working on Chrome, or all the people mentioned in this thread, responsible versus the product engineers that build it every day? It's an interesting tension. Like, this is something we faced at eBay to a certain degree, where like developers wanted to use React, and like, you know why we couldn't use React. But it's like at a certain point, the management wanted to use React as well, because the developers were unhappy. But the truth of the matter is, even if you use Marco, we'd look and be like, oh my God, what are they doing? Right? And this is the same in every company. I'm not trying to like, I'm just saying like, I think the challenge here is actually building stuff at scale with that many developers trying to work on the same project. And I don't know if it's even a technical issue anymore, which is interesting. But yeah, I don't know. It is hard when you like are pushing about technical performance things, and then you don't. How do you deal with like how do you measure that or show that at the community way, right? That does it, because they actually had an example where they said like this improved this loading time 60%, but holistically, what's the impact of these things? Google would know, but it's difficult when you're an individual developer out here trying to verify. Anyway, I don't know. It was an interesting thread. Right. The question is, search is 3 megabytes of JavaScript. So the argument is you can build a smaller search, perhaps. But when you think of what search does and what it's capable of and the way that it loads everything, it's like ads consideration, all those things. It could be a lot worse. I know that's not saying much, but it's very easy for us to be like, oh, well, I just built my example and it's way faster, right? Which, I mean, maybe this is the argument that people are using, and maybe only DX matters. But I think it could be a lot worse. Like, the whole reason Wiz exists is because it like lazy loads and can selectively control the different JavaScript that gets loaded into the package and only run the JavaScript that's necessary when it runs. There's a whole bunch of other garbage on top of that. I know this from eBay.com, between the way advertisements work and other kind of add-ons. The core search experience, even given that, is still pretty performant. If they could just gut it and start over again, I don't know how long before it just hit this anyways. Are people afraid that we'll get the result of DX with the performance of Angular? Well, if the performance of Angular, this would never fly. Like for what they need it for. Wiz is like very similar to Marco. There's a real performance shelf that they care about. Yeah, I mean, to be fair, this thread seems hating. I think that what they're trying to point, I think what he's trying to point out is that like there's a whole echo chamber on Twitter about these things. How does that reflect with reality? I don't know, man. If it rated after pain, I don't know against React. Yeah, does React ever claim that it's performant? See, that was cheeky there, and that's not called for. I'm sorry. It's just like this is the problem with this kind of stuff, and it's the reality. The best that anyone can do in these situations, generally speaking, is incremental improvements in certain areas where they can just make things a little bit better, right? But I mean, is this an opportunity for some newcomer to offer a better video service thing with like a nicer UI or something? I don't know. Like, yeah, that is true. Like, he was asking to get blocked. Yeah. There's also this. I feel like there's probably like the people Google. There's like made here syndrome concern. You know. That being said, I know how amazing the tech is of Wiz, and we'll hopefully understand that next week. But yeah, yeah, it's interesting though because you look at the efforts the Google Chrome team goes to improve performance. It's incredible. They try and work with everyone to just get it to that next level. Yeah, no, I don't think so. This is a problem with developing and scale in the way that our stuff works. The theory, at least, is that with something like resumability and fine-grained rendering signals, you can isolate the impact that any one developer has on how crappy the experience ends up being. Yeah, you can look at one large app with no idea how it's implemented and blame the framework. Yeah, definitely. That's the thing. You have all these platform engineers trying so hard to just make things better, easier for things, and then not to crap on the product guys. I've been there too. There's a gap there, but then it's like, then you have somebody else that's telling them that they need this, and this, and like these things aren't always aligned with each other. I mean, depending on the type of app, 3 MB of JavaScript is pretty bad. I mean, here's the question though. You guys all know that I run basically. I mean, let's look here. I'm pretty sure if I go to my network tab, we'll. Oh, not on this computer. I basically run perma disable cache, right? And like, okay, I got 1.2 MB here, but my point is, oh, and then some more stuff. But my point is, most of this is not critical blocking. It's just like this isn't even. Let's do something. Like this is an MPA. Every single search is a page load, right? This JavaScript might load in, but you can see most of it's lazy. Let's actually look at what loads in initially here. That probably isn't important for stuff. This is vitals. These are my let's actually open this in incognito window because I'm interested. Search, query crossing. My guess would be that the critical part of the page is delivered in the first 500 kilobytes. These three. I think everything else after probably doesn't matter. Anyway, I mean, we could look at. Okay, so first thing, definitely streaming going on. See, the HTML hasn't even all delivered and we're already processing stuff, right? What do you got here? Fonts coming in. We have. What's this? JavaScript. This looks like the main bundle. LCP is already done here. So they get the majority of the content at 400 milliseconds in this run. Before that, yeah, so yeah, obviously SSR'd, and then main bundle. What's this? Yeah, I don't know. Let's try one more. Wonder what's happening during this script running time. This is the part I'm most interested in. I feel like there's a bunch of work happening here. I don't know. It's hard to tell when the interactivity is actually opened. Like, I'm gathering because of the way Wiz works, you could probably interact with the page anywhere around here. But it's like, then what the hell is all this other stuff? Well, it's all the other stuff. Anyway, it's enough looking at that. I think building any app at scale is difficult. Demo apps are easy. Even startups to a degree are easier. Once you're pushed to actually like solve problems at a certain point, it becomes way harder for any framework. The framework is only the starting point. This is actually why I'm so big on the approach we've taken with signals and these primitives, because I expect this is why I never liked the meta framework. Like, to a certain degree, when you get to the real push comes to shove, all these like opinionated things where you think like, okay, this is how you do it, it all goes out the window because you ultimately just have to build what's fast and what works. And like like it goes beyond what like the happy path at a certain point, which is why, as I said, I like things like signals, because then it's like, look, you have the pieces. If this part isn't optimal enough, like, don't do it the solid way necessarily or the React way, but you still have you can interface with it in a very natural way no matter what you're doing or however you approach it, right? Like, you give people the building blocks and they aren't trapped in because, React re-renders, now you're screwed, I mean, you can always step out of it, but like getting back in is that much more of a hoop. Whereas like if you're like, okay, this is all I need, this like it just makes interfacing with the boundaries of what's expected much, I think, easier if you give people those building blocks. Yeah, no, we can ask Jadon about that, definitely. Okay. uh yeah. Anyway, I think we're done on this topic. Let's talk about solid start release. Which is the other thing. Attila over at React Paris had some fun with it. I'm not going to spoil anyone. Some people figured it out. Anyway, figure it out. Here's the announcement. Someone's like, Ryan would never say figure it out. I thought that was actually the funniest part about this. Are those notifications real? Ryan would never say figure it out. Yeah, you're right. But yeah, the solid start release has been a long time coming, and honestly, this was a big thank you message to everyone involved. I'm glad that people have responded well to it and taken notice. I wasn't sure, honestly. like when I started this, I was like, man, this is just too much work. And at many phases during this, I was just like, how are we going to maintain this? Because the important thing for a library of our size is being able to maintain it. And you know, with our user base, we have a fraction of the resources that other frameworks have. You know, like we we arguably out of the most, yeah, I mean, the number of people who get paid full time to work on Solid is, you know, basically is me, right? Um, we've been using grants and stuff. We get money for our open collective to sponsor fellowship programs. We have tons of people volunteering, getting stuff done. But it's like, it's it's why we got jammed up a bit on getting the signal stuff. It's why there's, you know, still work to be done. It's hard. You know, a lot of frameworks these days, you know, don't have a lot of resources. A lot of them maybe only have 2 or 3 people working on them, but 2 or 3 is still 2 or 3 times the amount of, you know, potential output that, you know, it's significant. There are frameworks like Vue which have shown that this open source model can work, you know, but even then Nuxt, you know, has a different set of people working on it. And we were trying to do solid start and solid, and I mean, it's tricky. Easy, sell it to Shopify. I don't know if in this market if anyone's buying, you know. I would love to do whatever it could to secure the future of Solid. I mean, that's no stab at Netlify or anything. It's just like where we're at, you know. If there's companies out there that want to see Solid getting further, I mean, you know, reach out to me. It's like I can be nothing but grateful for those who have helped us get to where we are. It's challenging, right? Like we've done a lot of really good stuff. We've seen the work at Solid has influenced the rest of the ecosystem. When I started this, I thought that no one would care. And now, other than React, pretty much every framework's on a trajectory path of basically doing the almost exact same stuff that we're doing. Like it, and it's not just like the signal stuff. I mean, that's obvious. It didn't stop 8 years ago or 7 years ago. I guess Solid technically came out almost exactly 6 years ago. So I'm going to assume people weren't familiar with these techniques before Solid open source. But let's say it didn't stop 6 years ago, you know, when these rendering techniques were made. Continue to work with Solid Start even. I mentioned it in the beta. We got a lot of, you know, influence from a lot of different projects here, you know, recognizing exactly what Remix did well, looking at the different routing patterns. I think like our routing was inspired by Nuxt initially, and server functions, or sorry, our API routes were inspired by SvelteKit. We kind of took our own take on server functions and route data, route actions, but the optimistic API came from Remix completely, right? And you know, all of these were really big influences, but on turn, I feel like we've influenced, continued to have an impact, like the whole server function thing. I came out, I believe, first in Solid, it preceded Next, preceded Quick, preceded whoever else. That kind of joining the RPCs with the actions. I think stuff like our work into single flight mutations. I already mentioned I think Remix is already working on it. So like, there's a lot more that's here to go. But like honestly, I can't picture getting here without what everyone else has contributed to this. And it's always like a bit of an uphill battle, but like we keep doing it because we're passionate about it, right? Elon for co-milling exchange rewriting Twitter. So solid to join. This node. I haven't been paying attention what's going there. Yeah, exactly. They Vue, I think, is probably the community most similar on this kind of trajectory where they kind of scattered around and use open source to try and get there. But as I said, like even stuff like Nuxt isn't wrapped in. But then like I'm sure if it wasn't, Evan's been amazing at, getting like beat teams and all this, different stuff. Um, both. They're our biggest they're our biggest open collective sponsor, and they fund me, which is big part for funding Solid. Like there's nothing else that can compare, honestly. Netlify has been amazing to me. But I mean, as I said, like it's hard. You want you don't one developer is great, but you at a certain point you want to be able to grow with it. Like I think there's Vercel has 3 developers. I think Next has, I don't know how many on Next. At least in the close to 10 range. I think maybe a little under. I don't know, maybe 6, 8. I don't know. And then you get into stuff like Facebook itself. Work on React. I say dozens, but like I'm pretty sure the number is over for these teams at the like Angular, Google. I'm sure the number is over 3, but probably under 100 or under. Like at that point to me that's almost like exponential, right? Like it's like the difference between 1 and 2 is huge. The difference between, you know what I mean, like because that's double your effort. The difference between 32 and 33, not so much. No one solves the double data problem today. I think there's a solution to it, but my point here is this release, um, doing Salt Start in general is very ambitious of us. I knew it was the right thing to do, but it's taken very long time. Not just because I'm a perfectionist. It's just it's important. And there's like, if it was me by myself, it would take another decade. Like, so many people have been involved in this project that doing their little part has made such an incredible difference. And like I tried to grab everyone who did any PRs, but then I realized after I used the GitHub API to get all the PRs that there's a lot of PRs that we closed not because they weren't good PRs, it's just like we solved them a different way or we did that. So I went through the list one by one afterwards, and tried to find anyone who had closed PRs on that I didn't merge who weren't already in the list and add them to the list. And like I really tried not to miss. Obviously, people report issues and stuff, and that would be kind of beyond my feasibility to be able to pull all those names down. But I really wanted to add everyone. Unfortunately, GitHub cut me off at 200. But yeah, this is everyone who submitted or submitted a PR, even whether it's merged or not, on the repo. And obviously all these companies as well. The big thing for me is recognizing that not all these people are associated with Solid anymore, and not all these companies exist anymore. Some of them went under because the economic, their startups or whatever, but they still put their money and their time in to make this possible. and it was cool to see because everyone got mentioned here. So when the release came out, they saw this. That's what I wanted to accomplish here. This release is called Clowntown, or Welcome to Clowntown, which is a little bit aggressive perhaps, but it was important to me. I don't know. I don't even know if people remember this reference, even if they even know. I didn't rehash it in here. I didn't need to drag things through the mud anymore, but it was important to me because at one point the Solid Star project, publicly was like, called Clowntown, essentially what we were doing over here. And it had a big impact on people working and maintaining the project at the time. A lot of people, we weathered the public, relatively well, I felt, and we represented ourselves. But when you're working in open source and you're not making money and you're not, like at a certain point you just kind of go, well, is this worth the headache? Do you pull away? Do you prioritize other things? And for me, I was just like, okay, no, like we have to show what it kind of focused in on me even harder to make sure that we reach this goal and that we do things better. But not everyone ultimately came out of the other side of that. I wonder if the other Ryan remembers this. Yeah, I mean, that's why I didn't want to be too descriptive. I didn't want to like necessarily, um, point fingers at another project or whatever. Who, as I said, made this was like what, a year and a half ago. Like we're all in a different place now. But it was a formative experience for people on the Solid team, not just Solid Start. It actually made a big difference, to realizing where we were in the Solid team. That was, I've never experienced public scrutiny like that. Randos, not even randoms, like, God, people like trying to like Matt Billman and the Netlify crew and being like trying to blame them and trying to like, I don't know, get me fired. I don't even know. It was like shame on you and all this stuff. And then, called into the integrity of the whole team. So that's why I named this release this, because it's kind of like a nod to the fallen heroes, so to speak. Everyone who got us here across the finish line, because I don't want to bring this into Solid 1.0 release. I want people to celebrate of what they can accomplish, the way they can build on the web, just how amazing the technology is and the DX and every bit of it. And maybe I needed closure a bit on the aftermath on all this. We never really talked about it. We talked about it a bit on stream, I guess, or maybe I was on guest stream, but this is how, for me at least, we know we made it. We did it. We started at one place. We learned. We conquered. We succeed. Right. Two Nikhils, be good. Yeah. He's other than myself, like he's the both of the top contributors there. Nikhil, this is everyone on the and this is some of the original docs work. Yeah, everyone on the first like 5 or 6 lines probably did a freaking ton of work here at some point. Because I think it actually ordered it in contribution until I started like adding stuff at the end. I do feel bad. There's a few people down here that I would give special shout out, like Paulo and DevRB, and I think there's another one in here. They worked on the Islands demo on that branch that took forever to get merged, and when it got merged in such a messy way that I think I lost most of their commit history. These guys did incredible work to prove the movies app which is like an incredible demo. Um, I they didn't get enough recognition as they deserve. I found their names through closed PRs where when I didn't merge the islands demo and then they were still working on it even afterwards, and I like couldn't merge the branches. I found them on those closed PRs and added them to the list, but they did way more for that than what actually shows on this. Like it was incredible to go over the list because I remember lots of those PRs and suggestions and things where people were excited about the project for a while and wanted to help, you know, uh, whether it was like little document changes or like, work on the CLI or, you know, yeah, there was like phases like where different developers would come in and do, a small handful of PRs to get their thing working or whatever, and they could come and go. But I looking at the list reminded me of that. Anyway. I'm excited for the future of the present. Yeah, we're close now. There's some bugs coming in, which is good. How many issues do we have right now? Yeah. Solid core bug. This one's apparently very hard to reproduce, so that one's going to be fun. Some Vinci issues in terms of style counting. This is someone trying to do something with Solid that doesn't really work, and I just haven't had time to tell them figure out what the right solution is. This is weird, but completely avoidable. This is probably a Vinci bug. Vinci. Yeah. Pretty good place, honestly. No, the clown thing. I'm done talking about clowns. I know this will be fun for the next like week or so. Um, it was important to me to finish that cycle. Thank you. Anyway, yeah. I'm sorry. This is a little much. It was an important release. It's been 3 years. I kid you not. It's been 3 years. It's funny. Last year we were celebrating with Astro, right? They were like, yeah, 3 years since the first commit on Astro. Um, Solid Start's first commit is probably around the same time. I mean, let's look. Vue 2. I mean, there's the Vite community getting in there again, or sorry, Vite 2. There's the Vue community getting in again to show us how their work on developer tools are just completely game changing in terms of what we're capable of, especially for library authors. I give them top marks on that side. Yeah, when's this initial commit? Okay, not quite. Next week, April 1st. I was playing around with this before, but obviously I didn't publish it up yet. But yeah, like basically around the exact same time that Astro was starting, I was like, yes, I need an SSR solution. Look, create solid, like stuff's already actually in here at this point. So yeah, I had started this around the same time, around the Christmas break of 2021. It was before Solid 1.0 even. If we actually look at the package JSON here, what version of Solid were we on? See if I can find it. See these examples, package JSON. Solid.js 0.25. There you go. So yeah, I mean, we had everything we need already back then. We had out of order streaming, suspense on the server, you know, transitions. Why not? Thanks, Shy. Oh, this tweet is from an hour ago. I'm going to open this up off screen just because I could decide what I want to do with it. Oh, oh man. That one sentence. Oh, okay. I'm going to bring this up because I missed this. Did that one sentence make it somehow? Did that one sentence make it somehow on this? We have a complete docs rewrite, but that opening sentence somehow made it. How did this is even possible? Is that what? I I don't even know. We literally deleted the project and started over from scratch. That one sentence somehow still persists here. That's crazy. That's no, I mean he's right. I have no idea how that I have no idea. I mean, at this point, we're on like the third rewrite of the docs. Like, we don't even like this doc site is pretty much dead. Oh no, it made it here. How does this stupid sentence just keep on making it here? What? How did this like it's like the only part of the it's funny because like all yeah. Do they still have it? At least like I honestly have no clue how this one sentence just keeps on. I guess it's technically two sentences, but it just it's probably like just such a well written like I wow. I have no clue. The funny thing is I guess I don't have the current yeah, I'm gathering it's like not there anymore, but Yeah. It's the old docs, right? It just, yeah, it's just guides. Okay, guides. Is the guides section still here? Let's see if it's okay. I, I I don't even understand how this is possible, but because the it was moved out of our repo, which is where the problem was. Like it was in like uh, Nikhil was doing like some simple how should I put it? Like he was doing like some prototyping in the solid repo, and then they wanted to set up a separate docs repo, and so they moved the project. It got moved out of the solid repo, and then other people were contributing there. So I never actually saw the stuff happening. And then we started the project new inside the start repo after the whole thing happened. I I just don't I don't know. That's definitely odd. I almost like want to go back through commits to understand how how this could possibly happen. But, you know, we're kind of at the end of our stream here. I've got it there for sure. I mean, it's funny if it's just like that one sentence that did it. It's a little bit comical. Like it's like, but like I just I'm at a loss here because like I don't even know how many commits to go back. Like we have fork solid start. Like like if we go back to let's say like the docs aren't even I don't even remember when that happened. It was like July or something. Yeah, it's funny because like the whole thing wasn't actually in the repo. So yeah, I this would be yeah, this is like try and go through a million Nikhil PRs. Yeah, I don't know. Go to that file and check the history. Yeah, okay, you're right. That's something I can do relatively easily. Okay. Docs. I'm actually just going to do it right here if I can. I do have to docs, core concepts, routing. Do I not have, am I so out of date here? It's funny, like VS Code, I usually have like the blame thing here. I haven't updated this forever. guess I could do it on GitHub as well, but it's just packages, start. No, not start. Packages. It's not packages. It's the thing is docs might have moved at this point. It might be. This might be not advanced. Sorry, core concepts. Routing. Blame. Yeah, I don't know. I guess it came over with the initial commit. I don't know. Yeah. Oh, yeah. But I mean, yeah. Anyways, let's just go. Anyways, crazy. That's a crazy way to end the stream. But yeah. Anyway, I'm dumbfounded. But yeah, I'm way over. I'm over time. We'll have to pick up next week. Anyway, you all have a good night. I gotta go. So until next week, catch you guys. Have a good one.